Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the strangest and most haunting ideas ever whispered by science: quantum immortality. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into quantum immortality together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here quietly unfolding the story. Imagine this, a theory so audacious that it suggests consciousness might continue forever, not through myth or faith, but through the endless branching of reality itself. It begins, as so many strange stories do, with a quantum world, the secret theatre behind all things, where particles don't behave like neat, obedient marbles, but like restless waves of possibility. Quantum mechanics tells us that before anything is seen or measured, it exists in all possible forms at once, everywhere and nowhere, as though reality were undecided, waiting to choose its next line in a play. You might picture an electron, that tiny traveller, moving through the dark like a ghost. It doesn't choose one path but many, slipping through space like a whisper through fog. When it's left alone, it hums to itself in a state we call superposition, a word that sounds complicated but means something simple and beautiful, that the world hasn't made up its mind yet. It's as though the universe is still dreaming, and observation is what wakes it. One of the clearest windows into this mystery is the double-slit experiment. Imagine a wall with two small openings, and you fire one electron at a time toward it. Each electron seems to act as if it travels through both slits simultaneously, creating delicate ripples of interference on a screen beyond. Each ripple is a mark of probability, not of where the particle is, but where it could be. Yet the moment we look too closely, the moment we place a detector beside one of the slits to ask which path it took, the pattern vanishes, the interference fades, the mystery collapses into something ordinary, two smudged marks, as though the universe has closed a secret door. What's strange is that this isn't some quirk of experimenters in lab coats. It's the quiet behaviour of everything that exists. Even you, every atom in your body, is made of quantum whispers that only appear definite because of a vast web of interactions called decoherence, which binds you into this steady, waking world. Without it, your thoughts would spread like mist across possibility, never forming into the person listening here tonight. For a century, scientists have argued over what this means. The old guard, led by Niels Bohr and his followers, said the act of observation itself forces the world to choose. They called it the Copenhagen interpretation. When you measure, the wave of possibilities, the wave function, collapses into one outcome, guided by something called the Born rule, a rule that simply says, the brighter the wave at a certain spot, the more likely that's where reality will land. But what exactly collapses? Why does watching change being? No one can quite say. Even Richard Feynman, the brilliant mind behind quantum electrodynamics, once admitted with a wry smile, "I think I can safely say that nobody understands quantum mechanics." And perhaps that's what makes it so mesmerizing. Quantum theory isn't just a description of particles, it's a riddle about existence itself, about why there's one version of events rather than all of them at once. Each time you blink, reality seems to decide which story continues and which fade into silence. The question that lingers is, where do those other possibilities go? Do they vanish? Or do they continue elsewhere, just beyond our reach? That's where tonight's story truly begins. with a young graduate student in 1957 named Hugh Everett, who dared to suggest something astonishing, that the wave never collapses at all, that every possible outcome happens, not in imagination, but in reality. He called it the relative state formulation. The rest of the world would one day call it the many worlds interpretation. Everett imagined the universe as a single vast wave that never stops unfolding. When an electron takes two paths, it doesn't choose one, it creates two worlds. When you make a decision, however small, the universe might quietly split, weaving a new branch where each possibility continues. It's not a violent splitting, not a pop or tear in space, more like threads of silk unspooling from a single cocoon. If this is true, then you're not just one self, but an ocean of selves, each tracing a slightly different story. There is a version of you that stayed home instead of leaving, that laughed instead of crying, that turned left instead of right. Each path real, each moment alive somewhere in the grand tapestry of possibility. But what happens then to death? That solemn certainty that every story must end. If there are countless branches of you, and in some you survive what in others destroys you, could it be that from your own point of view, you never experience an ending at all? That consciousness, the quiet witness of your world, might always find itself continuing, drifting from one surviving branch to the next, endlessly, softly, forever. This is the seed of quantum immortality, the strangest idea in all of science. It sounds like philosophy or fantasy, but it's drawn from the same mathematics that describe lasers, atoms, and the computers that may be humming gently near you now. It doesn't promise eternal youth or comfort. In fact, it opens unsettling questions. If you can never truly vanish, what becomes of meaning? If every outcome exists, why do you experience this one? Tonight we'll move slowly through that maze, from the foundations of quantum mechanics to the shimmering edges of consciousness. There will be no equations, no heavy symbols, only images like reflections in water. We'll meet Everett, Tegmark, and the philosophers who tried to measure existence itself. And we'll listen together for what their ideas whisper about life, awareness, and the endlessness of being. So take another slow breath. Feel the small weight of your body resting in this moment. One branch of infinite possibility. Somewhere, another version of you might already be asleep. Another might be wide awake, staring at the stars. But for now, this is the one that's here, breathing, listening. And as the universe hums quietly around us, the story of your existence and all its reflections begins to unfold. As we drift further into the story, it helps to linger for a moment on the feeling that started all of this. Confusion mixed with awe. When physicists first peered into the quantum world, they didn't just find new rules, they found uncertainty woven into the fabric of being. The universe, they realized, isn't a clockwork machine ticking with perfect precision. It's more like a shimmering cloud of possibilities, gently vibrating with chance. Albert Einstein, whose mind helped build the bridge between the known and the unknowable, once said, "God does not play dice with the universe. He wanted reality to make sense, to be ordered, causal, predictable. But the quantum world seems to whisper otherwise. It doesn't roll a single die. It rolls countless ones at once. Every event is a soft negotiation between potential and outcome, like a coin that keeps spinning through eternity, never quite landing. To the quantum physicist, that spin is what defines existence. A particle isn't here or there, but both, until it's forced to decide. That state of graceful indecision is what they call superposition. You can think of it not as an object split in two, but as a melody containing many possible notes. When no one listens, all the notes are playing at once, a kind of cosmic harmony suspended in air. The moment you listen, when you make a measurement, the melody collapses into a single tune. The world in that instant chooses. Imagine you're in a dark room with a single candle. The flame flickers, casting moving shadows on the walls. Now imagine that instead of one candle, there are thousands, each lighting and dimming with every heartbeat of time. The world you see, the one that feels stable, is only one pattern of those overlapping flickers. Somewhere beneath the surface, the light is always trembling between possibilities. When you drop a pebble into water, it creates rings that ripple outward, colliding, cancelling and amplifying. Superposition behaves much the same way. In the quantum world, those ripples represent the probability of finding a particle at a certain place or state. Some waves strengthen each other. Those are the likely outcomes. Others cancel out. The path's reality quietly erases. There's no need to imagine formulas or symbols here. It's enough to picture an endless pond, where each disturbance tells a story about what could be. This was more than a poetic idea. It was testable, visible. The double-slit experiment, that quiet miracle of science, became the first keyhole into this mystery. Fire tiny particles, one by one, at two narrow openings, and you don't get two tidy marks on the wall behind. You get a pattern of bands, light and dark, presence and absence, proof that even a single particle can interfere with itself. It's as if it travelled both paths, greeting itself on the other side. But here's the part that still makes even seasoned physicists shake their heads. The moment you add a simple detector to see which slit the particle went through, the interference vanishes. The pattern of waves becomes a pattern of bullets. The universe stops acting like a dream and turns solid again. Somehow, the mere possibility of knowledge changes what's real. You might think this has something to do with human consciousness, as if the mind itself collapses the wave. But modern physicists see it differently. It isn't the act of thinking that changes reality, it's interaction. Even a wandering photon brushing against the particle can make the universe decide. Observation in this sense isn't about awareness, it's about entanglement. The spreading of contact through everything that exists. It's a beautiful thought, if a little dizzying. The entire world in conversation with itself, every atom whispering to every other atom, deciding collectively what will be. This process of mutual influence, of endless conversations, is what slowly shapes the reality we call classical. The stable world of chairs, stars, and sleeping cats. And yet, this is where our intuition fails us. In daily life, we don't experience 1,000 versions of a cup of tea, or 2 possible mornings unfolding at once. The strange quantum ballet seems to vanish at our scale. Something, it appears, bridges the microscopic realm of chance and the macroscopic world of certainty. That bridge has a name: decoherence. Decoherence isn't collapse, it's more like forgetting. As particles interact with their environment, their delicate quantum states blur into countless possibilities, each incompatible with the others. The result is a soft separation of worlds, like ripples spreading too far apart to ever touch again. To us, the interference disappears not because it's destroyed, but because it's drowned out in an ocean of complexity. In this way, the universe hides its own multiplicity. Beneath the quiet solidity of your desk, your skin, and the moon above you, there's a storm of overlapping probabilities, branching and fading faster than any mind could trace. You never notice because you're part of that storm, a wave among waves. Einstein couldn't accept it. He wanted the cosmos to play by rules written in reason. But Niels Bohr smiled at the uncertainty. He said, "Stop telling God what to do." For Bohr, the dice weren't a flaw, they were the pulse of reality. Perhaps the universe isn't random at all. Perhaps it's alive in its own way, exploring every possible pattern, only some of which we get to see. It's humbling to think that the same principles guiding this ghostly world also govern you. Every neuron, every molecule of oxygen you breathe, vibrates with that same uncertain rhythm. The next word you hear, the next thought that flickers across your mind, might already exist in some invisible field of possibilities. You're part of the same shimmering equation, only expressed in heartbeat and thought. And maybe that's the quiet wonder of quantum mechanics. It reminds us that certainty is an illusion, that every moment is a choice between infinite could-bes. Life itself is a kind of measurement, a narrowing of the infinite into the single experience of now. If we follow the thread a little further, we'll see what happens when someone decides not to collapse the wave at all. When a mind dares to take the mathematics literally and imagines that every possibility, every outcome continues somewhere. From that courage, or perhaps that madness, was born the many worlds interpretation, a vision of infinite realities quietly unfolding side by side. So take a gentle breath and let the idea settle. The dice are rolling, everywhere, forever. You may not hear them, but their rhythm is the heartbeat of the cosmos itself. Our quiet exploration now turns to one of the simplest yet strangest stories ever told in science, the tale of an electron and two narrow slits in a wall. It's a story that seems so small, so harmless, yet it contains a secret vast enough to challenge every idea you've ever had about how reality works. Imagine a laboratory so still you can hear the faint hum of electricity. On a metal plate, two tiny slits are carved, small enough that even light itself seems hesitant to pass. Across the room, a screen waits in the dark. A scientist switches on a machine that fires single electrons one at a time, like the gentlest rain of invisible marbles. The first one strikes the screen, leaving a soft mark of light, then another, then another. If the universe were made of simple, solid particles, we'd expect each electron to behave like a pebble tossed through one slit or the other, forming two tidy clusters behind the holes. But that's not what happens. After a while, the pattern on the screen begins to shimmer into something utterly unexpected. A series of bright and dark bands like ripples on the surface of water where waves overlap. It's as if each electron doesn't choose between the two slits, but somehow travels through both at once, whispering across space to itself. Every possible path the electron could take is part of a single story told all at once. A story written not in lines or letters, but in probability. That strange, ghostly pattern, the interference pattern, is the signature of superposition. It's what happens when possibilities aren't forced to decide. In the language of physics, the electron is described by something called a wave function, which spreads out like a mist of chances, assigning to each point in space a kind of amplitude, a measure of how strongly reality leans toward one outcome or another. But let's set aside the equations. You don't need to see the symbols to feel what they mean. Imagine instead a soft, continuous fog, drifting through both slits at once. Where its layers overlap, the mist brightens. Where they cancel, the fog fades to shadow. The result is beauty. Not a mathematical beauty, but a physical one. Nature painting interference fringes as if to remind us that it doesn't choose until it has to. Yet when we place a detector beside one slit to ask which path the electron takes, everything changes. The interference disappears. The smooth ripples collapse into two simple smudges. The universe, it seems, has been caught in the act of deciding. It's tempting to think that our observation, our awareness, caused this shift. But the truth is subtler and even more mysterious. It isn't that human eyes carry special power, it's that any interaction, however small, creates entanglement, a kind of handshake between the electron and the rest of the universe. When even a single photon brushes against it, the electron's delicate uncertainty is scattered outward, woven into the larger world, until all trace of its indecision vanishes. You could think of this as a kind of cosmic gossip. The electron's secret, which path it took, spreads instantly to its surroundings, and once the environment knows, the secret is out. The world, in its great interconnectedness, refuses to keep superpositions private. It demands coherence, clarity, decision. And so, the pattern disappears, not because the quantum dream ends, but because it's been drowned out by countless conversations. This phenomenon, which physicists call decoherence, is how the classical world emerges from the quantum fog. It's what allows you to sit still, to hold a cup of tea, to believe that things have definite shapes and places. It's why cats, thankfully, aren't found both alive and dead when we open the box. The quiet, continuous blending of countless particles turns probabilities into permanence. It's as if every grain of reality agrees, softly but firmly, let's settle on this version of events. And yet, a haunting thought remains. If the electron really did travel through both slits, what happened to the other path when we chose to look? Did it vanish? Or is it still out there, humming faintly like an echo that never fades? This is where the familiar world of logic and the poetic edge of physics begin to blur. For if we follow Everett's reasoning, the idea that the wave never collapses, then those other paths don't disappear at all. They simply drift beyond our reach, like parallel melodies we can no longer hear. In one world, the electron passed through the left slit, in another through the right. Both are real, both complete, both continuing. And if that's true for a single electron, why not for everything? Why not for you, standing at some crossroad years ago, wondering which way to turn? Perhaps one version of you took the left path and another turned right. Each still exists, each thinking itself to be the original. The universe, under Everett's view, never makes a final cut. It just keeps weaving. You can almost feel it, a quiet trembling at the edge of certainty. Reality is no longer a single thread, but a fabric, constantly splitting and recombining. You live on one of those threads, convinced it's the only one, while infinite others ripple silently beside it. If this sounds abstract, think of sound itself. When a singer holds a note, your ears hear one tone, pure and clean, but in truth, that note contains harmonics, multiple frequencies vibrating together, some high, some low. You hear a single song because your mind merges them into one. The universe may be doing the same, singing infinite harmonics of reality, all blending into the illusion of one world. What we call a measurement is simply the universe choosing which melody to let us hear. But the others keep playing, unseen, unending. For a moment, let your thoughts drift through this image, electrons walking through two doors, light splitting and merging, the world unfolding from one possibility into another. Somewhere in that quiet complexity lies the seed of what will later be called quantum immortality, the idea that if every path exists, there must always be one where you go on. But for now, it's enough to marvel at this smaller miracle, that even a single particle can behave like an entire universe of possibilities. The next time you switch on a light or watch dust glint in a sunbeam, remember that those tiny specks are still playing that ancient game of chance, still whispering through the double slits of existence, still undecided until they must be known. And as we continue this journey, the mystery only deepens. If the act of measurement is what decides what's real, then what decides the measure? What gives one possibility its weight, its louder voice among all the others? Our path now carries us toward that question, into the quiet mathematics of probability and the strange rhythm by which the universe chooses which notes of itself to play. From here, the story opens into one of the most beautiful and unsettling ideas in all of physics: entanglement. It's a word that sounds poetic, and in many ways, it is. To be entangled means to be connected in such a way that the state of one thing instantly shapes the state of another, no matter how far apart they drift. You can imagine two dancers who begin their performance holding hands. Even when the stage lights dim and they move to opposite sides of the theatre, some invisible rhythm keeps them in sync. When one turns, the other follows, as though guided by a shared memory. In the quantum world, this invisible rhythm isn't metaphorical. it's real. Two particles can share a single description, a single wave of being so deeply that measuring one immediately tells you something about the other, even across galaxies. In everyday life, we're used to things having separate existences. The teacup on the table is not the spoon beside it. Your heartbeat isn't tied to the flicker of a faraway star. But at the quantum level, separateness begins to blur. When particles interact, they don't just bounce away. They merge their stories. Their wave functions overlap, creating a joint narrative that only makes sense when seen together. Once entangled, they are forever part of the same sentence in the universe's language. The most famous example came from the minds of Einstein, Podolsky, and Rosen, three physicists who tried to show that quantum mechanics couldn't possibly be complete. They imagined a pair of particles born together and then sent flying apart. According to quantum theory, until one particle's spin, its tiny magnetic orientation, is measured, both spins exist in a superposition of up and down. Yet if you measure one and find it up, the other instantly reveals itself as down. To Einstein, this felt impossible. He called it spooky action at distance, a phrase half amused, half uneasy. He believed that something unseen must connect them, a hidden signal or rule. Decades later, experiments proved him wrong. When physicists tested entangled particles over vast distances, the results matched the quantum prediction every time. No secret signal could explain it. The connection was deeper than space itself. Measuring one didn't send information to the other. It simply revealed that they had always been parts of the same whole. The fabric of reality, it seemed, was not stitched together by threads of matter, but by relationships. To understand this softly, you might picture a coin spinning in the dark. It's both heads and tails until you catch it. Now imagine two coins spun together so that whatever side one lands on, the other shows the opposite. They could be in different rooms or even on opposite sides of the earth. Yet the moment one coin falls, the other falls into harmony. It's not that one causes the other, it's that they're both parts of one dance. In more poetic terms, the universe doesn't just contain things, it contains connections. The things are just points in a web of interaction. Even your thoughts are woven from entanglements. Neurons sharing electric whispers, molecules vibrating in rhythm, atoms still echoing from collisions that happened in the ancient stars. The same principle that ties two electrons together also binds the entire cosmos into one breathing, murmuring whole. Entanglement is what allows information to travel through the quantum world. It's the reason quantum computers, still in their infancy, might one day process knowledge in ways classical machines never could. Not by flipping bits of zeros and ones, but by letting all possibilities coexist and intertwine. But tonight, let's not chase the engineering of it. Instead, feel the quiet wonder of what it means. When you look at the night sky, the light from those distant stars has been travelling for millions of years, yet some of its particles might still be entangled with atoms here on Earth. In some abstract but genuine sense, you're already touching the stars. The mathematics behind entanglement can be written as tensor products and complex amplitudes, but let's translate it into something softer. Imagine a musical chord. A single note is simple, pure, clean. But a chord with multiple notes played together creates harmony, tension, and colour. The beauty of the chord doesn't belong to any one note. It exists only in the combination. Entanglement is that harmony, a pattern that transcends its individual players, and once you see the world this way, you can't quite unsee it. Every interaction, every conversation, every glance is a kind of micro-entanglement. When you meet someone, you share a moment of correlation, a connection that lingers even after you part. The universe too behaves like that. It remembers, quietly, every meeting. Nothing ever truly happens in isolation. Now here's where the story takes a quiet, dizzying turn. If the universe is one vast entangled whole, then when we talk about a measurement, what are we really measuring? We can't peel away a system from its surroundings. Everything is wrapped together. When an electron meets a detector, they form a new, larger wave of possibility that includes both. And when that detector meets the scientist, the entanglement spreads again. The chain continues, reaching outward until the entire environment, the air, the instruments, the atoms in the walls, becomes part of one shared description. This spreading of entanglement is what we call decoherence. It's the quiet diffusion of quantum possibilities into the classical world we know. The equations describe it as phase information being lost, the delicate interference washed away by countless interactions. But in gentler terms, decoherence is like ink dissolving in water. Once the colour spreads, you can no longer tell where it began. The waves that once danced together drift apart, never to interfere again. Each becomes its own quiet reality, softly detached from the rest. That's why, in the end, we see a single outcome. Not because the other possibilities cease to exist, but because they've moved beyond reach, into branches that can no longer communicate with ours. It's not destruction, it's divergence. The universe isn't collapsing, it's expanding sideways, and this, more than anything, is what led Hugh Everett to his great leap. The idea that all those branches continue. Each possibility, once decohered, becomes its own world. Entanglement doesn't just connect, it also divides. Every handshake of atoms creates a new chapter in the story of existence, a parallel strand of history woven into the greater fabric. It's strange to think that such a profound vision could begin with something as small as two particles in sync. Yet it's often in the smallest things that truth hides most clearly. Beneath the quiet hum of reality, everything still holds hands with everything else, even as those hands slowly drift apart. If we follow this thread a little further, we'll find ourselves standing beside Everett again, looking not at particles but at entire universes, branching endlessly from a single cosmic root. Each world self-contained, silent, and whole. And somewhere among them, one version of you still listening, still breathing, still alive in this exact moment. If we follow the thread a little further, we find ourselves in the mid-20th century, where a young physicist named Hugh Everett sat awake at night, staring at the mathematics that described the entire universe. To him, the numbers didn't look like abstractions. They looked like music, one long continuous score with no rests, no silence, no final note. In that music, he could not find any instruction that said the song should ever stop. According to the equations, the wave function, that soft cloud of possibility describing everything, didn't collapse when a measurement was made. It simply evolved, calmly and continuously, according to one simple rule. Each possibility unfolded into its own melody. Everett's realization was radical, but elegant. There was no need for mysterious collapses or hidden dice throws. The universe, he suggested, keeps every verse of its song. He imagined what this might mean. Every time an event could go one way or another, an atom decaying, a particle spinning up or down, a heart deciding yes or no, the universal wave didn't choose. It branched. One outcome flowed into one branch, another into a second, both equally real. Each branch continued its own story, oblivious to the other. The world he proposed wasn't a single river of time, but a delta, endlessly dividing and recombining, a labyrinth of streams spreading across an infinite landscape. When Everett first shared this idea in 1957, the reaction was silence mixed with discomfort. The Copenhagen school, then dominant, preferred its practical rule: measure, collapse, move on. They cared about predictions, not metaphysics. Everett cared about consistency. If the equations worked for electrons, he argued, they must work for people too. There could be no line where the quantum stopped and the classical began. The observer was part of the observation, another ripple in the same wave. To understand this without any mathematics, imagine a wide ocean. The surface isn't flat, it's filled with waves of every size and rhythm. When one wave meets another, it doesn't destroy it. Both continue, overlapping, passing through each other, carrying on in their own directions. That, Everett said, is how reality works. The apparent collapse we see is just our limited view from one crest of the sea. The rest of the water keeps moving. This idea sounds dizzying, but there's a strange comfort in it. The universe, rather than picking and choosing, is generous. It keeps everything. No outcome is ever truly discarded. Somewhere, each possibility continues, like pages bound together in a cosmic diary. In one entry, you decide to stay home. In another, you step outside and meet someone who changes your life. In yet another, perhaps nothing happens at all, and that too becomes part of the grand collection of worlds. When Everett's friend, the physicist Bryce DeWitt, first heard the theory, he admired the mathematics but couldn't shake a feeling of strangeness. "I don't feel like I'm splitting into copies of myself," he confessed. Everett smiled and asked, "Do you feel like you're orbiting the sun at 30 kilometers per second?" It was his quiet way of saying, what feels intuitive has little to do with what is true. The world rarely asks for our comfort. Over the years, what once sounded like fantasy began to gain quiet respect. As experiments grew more precise, nothing in quantum theory contradicted Everett's picture. The many worlds interpretation, as DeWitt later named it, became one of the leading explanations for why quantum mechanics works without mystery. There is no special rule for measurement, no sudden collapse, only the unfolding of possibilities through a single unbroken law. Yet even as the idea took hold, its emotional weight began to sink in. If the wave never collapses, then every decision you've ever made still echoes somewhere. The versions of you who spoke, stayed silent, left, returned, they all exist, each believing they are the real one, and perhaps they're right. From within each branch, the others are unreachable, faded behind walls of decoherence that keep their stories separate. Think of it like looking into a hall of mirrors. Each reflection seems solid and complete, yet you know they're all connected by the same source, you. The reflections can't talk to one another, they only shimmer in parallel. Each is a self-contained world, lit by the same light, but unaware of the others. Everett didn't think of this as multiplying people. To him, the person who continued after a measurement wasn't a copy but a continuation, as natural as walking through a doorway. In each branch, memory flows seamlessly, unaware of the split. You never feel the divide, you only ever live one continuous story. But from the outside, from the mathematical view, the universe has quietly doubled. What's remarkable is how calm the equations are about all this. There's no drama, no explosion of new realities, no thunderclap. The branching happens as smoothly as a breath. One possibility fades into two, then four, then countless more, all separated by tiny shifts in phase, that subtle rhythm that governs how waves interfere. The technical language describes this as unitary evolution, but in simpler terms, it's just the world keeping perfect balance, like a dancer who never loses her step. It's tempting to imagine that these worlds are stacked on top of each other like invisible layers. But that's not quite right. They don't exist in different places. They're different arrangements of the same underlying fabric, patterns in the same ocean, waves that can no longer interact. The universe doesn't expand in space when it branches. It expands in possibility. If that sounds abstract, think again of the quiet moments in your life when you faced a choice that felt defining. To speak, to leave, to forgive. In the Everett picture, none of those choices erased the others. Each became its own melody in the grand song of being. Somewhere, all versions of you still exist, walking their separate paths beneath the same cosmic sky. This view can feel both comforting and disorienting. Comforting because nothing is ever truly lost. Disorienting because it blurs the notion of identity, what it means to be you. If all your possible selves are real, what connects them? Is the self a single flame, or a constellation of sparks scattered across infinity? Everett himself lived a short, complicated life. His theory was ignored for years, his career never quite stable. Yet, in the strange irony of the universe, his idea survived, thriving in branches of thought that he never got to see. In one world, perhaps, he received the recognition he deserved. In another, he kept working quietly, content to know that the mathematics was right. The thought lingers softly, maybe both are true. And as we drift further along this river of branching realities, the next question rises naturally, almost shyly. If all these worlds exist and every outcome is realized somewhere, what does that mean for mortality? For the quiet boundary between living and not living? Could there be branches where your story simply goes on, uninterrupted? The path now carries us toward that question, into the eerie experiment that first dared to test it, the one that earned the name quantum immortality. As we drift further into Everett's vision, the air seems to thin with wonder. The idea that every possibility unfolds somewhere feels impossible, and yet quietly right, like a dream you can't disprove when you wake. The mind searches for something to grasp, but the truth here is missed. The world does not leap from one outcome to another. It glides, softly, continuously, through a sea of diverging realities. Everett's insight was that branching is not an explosion of universes, but a gradual separation, guided by what physicists call phase coherence. In mathematics, these phases are like beats in a rhythm. When they stay aligned, waves can interfere, creating the bright and dark fringes of possibility. But as more particles join the dance, their rhythms drift apart. The harmony dissolves. What once sounded like a single melody becomes a whispering crowd of independent voices. That slow fading of harmony is decoherence. You don't need to picture equations to feel it. Imagine two tuning forks struck at once. At first, they sing the same tone, vibrating in sympathy, but as moments pass, one vibrates a little faster, the other a little slower. Their voices blur until the music splits. No longer one note, but two, vibrating separately. In that instant, interference ends, and the two sounds go their own way. The universe does the same, again and again, every time a particle collides or a photon strays. This gentle, ceaseless process means that the splitting of worlds is not something we'd ever notice. It happens everywhere, always, silently. There is no flash of light, no thunderclap announcing a new universe. Instead, the rhythm of existence simply drifts, dividing one seamless whole into branches that can no longer speak to each other. Bryce DeWitt once told Everett that he didn't feel as though he was constantly splitting into copies of himself. Everett replied calmly, "Do you feel yourself orbiting the sun at 30 kilometers per second?" The question hung there, both simple and profound. Motion, after all, is relative. You don't feel the earth racing beneath your feet, and yet it is. The same, Everett suggested, is true of branching. It is real, but unnoticed, woven into the very flow of time. Think for a moment of all the unnoticed motions you live within. The planet spinning, the heart beating, the thoughts forming. Each change is smooth, natural and unremarkable until you stop to look. So too with the splitting of worlds. It doesn't require you to be aware. It requires only that the universe keep playing its own rhythm. If you could somehow step outside of it, you'd see a breathtaking sight. A vast, shimmering web of worlds unfurling from every event since the dawn of time. each branch tracing its own story, each decision creating a fork that multiplies possibilities beyond number. It isn't that the universe is infinite in space, it's infinite in narrative. But what's striking is how ordinary this process is. Everett's equations didn't demand anything magical. They simply removed the rule that said, collapse the wave. Instead of stopping, the math continued. Quietly, deterministically. What we call randomness is just our limited view of one strand in the tapestry. The grand pattern, when seen as a whole, is smooth. Nothing is lost, nothing is uncertain. To visualize it, think of a film projector playing a movie. Each frame appears one after another, giving the illusion of motion. But the film reel itself holds all frames simultaneously. The story already exists, past, present, and future, waiting to be lit. The many worlds interpretation tells us the reel doesn't just contain one film, but countless variations of it, all projected at once on invisible screens we'll never see. We experience only the one where the light happens to fall. There's something comforting about this view. It removes the violence from creation. Instead of abrupt choices and endings, the universe becomes an ever-expanding sea of coexistence. All that could happen does happen, softly, without judgment. The worlds don't fight for existence. They simply diverge like leaves floating on separate currents. Some philosophers found this vision intoxicating, while others found it unbearable. If every possibility occurs, then where is meaning? If all choices are made somewhere, what does it mean to decide? Yet perhaps the answer lies in how we experience life, not how we calculate it. Meaning, like consciousness, may be local. A candle's glow in the dark, precious precisely because it illuminates only one corner of infinity. To Everett, the beauty of the theory was that it didn't need anything extra. No divine dice, no collapse, no hidden mechanisms. Just the universe unfolding according to a single rule. The wave evolves. In technical terms, it evolves unitarily, which simply means it does so perfectly, conserving all information. Nothing is erased, not even death, only moved beyond reach. If this sounds abstract, you can bring it closer with something simple: breath. Each inhale begins as one flow of air. As it enters your lungs, it divides. Oxygen branching into your blood, carbon dioxide drifting outward, countless molecules colliding and parting ways. Yet you never feel the divisions. You just breathe. The body continues, unaware of the millions of worlds forming and dissolving within it every second. And that, Everett might say, is the nature of existence. We're not separate from the branching. We are the branching, localized awareness riding one small wave in a vast ocean of evolution. What we call the present is simply the branch where our consciousness happens to rest. All the others continue without us, unseen but real, their rivers flowing beside ours. Over time, as decoherence deepens, the branches become sealed off. Their phases, those delicate rhythmic alignments, grow so mismatched that no bridge could ever connect them. This is why we never see evidence of the other worlds, though they might be infinitely near, layered like reflections in glass. It's not that they're elsewhere. It's that interference has died away, leaving only quiet separation. In a way, it's poetic justice that the mechanism for multiplying worlds is not chaos, but stillness. The more interactions happen, the more decoherence grows, and the more peaceful each branch becomes, a self-contained reality unaware of all others. The universe divides not through violence, but through harmony fading. Everett saw this as liberation. There was no need to carve an arbitrary line between observer and observed, no privileged mind collapsing waves. Reality was whole, complete, and self-consistent. We are simply passengers in its unfolding, witnesses to one melody among infinite others. If we follow that melody a little longer, we'll reach a curious question. If every possible outcome exists, could there also be branches where the impossible survives? If death itself is merely one kind of outcome, then somewhere, consciousness might continue down the branch that avoids it. Somewhere, the awareness that calls itself you might never find an end. The thought is both comforting and chilling. But for one physicist decades later, it became an irresistible experiment of imagination. He asked, if the universe truly keeps every version of you, could there be one in which you live forever, not through miracle, but through mathematics? And that question, soft and strange, is where our journey next takes us. If we follow the trail of thought further still, it leads us outward, beyond electrons, beyond laboratories, into the enormous quiet of the cosmos itself. If Everett was right, then the branching of worlds didn't start with us. It began with the very birth of everything. Each flicker in the infant universe, each uncertain vibration of energy would have spawned its own version of events. From that first shimmer, countless threads of existence would have unfurled, each one weaving a different history into the same cosmic tapestry. It's strange to imagine the Big Bang not as a single spark, but as a fountain of endless possibility, like a bundle of ribbons tossed into the air. As the universe expanded, those ribbons stretched, twisted, and multiplied. Every atom, every gust of starlight, every breath of wind on every planet became part of this branching cascade. The many worlds interpretation doesn't just whisper that we live among other universes. It suggests we are surrounded by them, woven through them, like threads sharing the same fabric. The scale of it is almost impossible to hold in the mind. There are more branches than there are atoms in all the stars we can see, more histories than there are grains of sand on every shore of time. Somewhere among them, there's a branch where the dinosaurs never vanished, another where the continents drifted into shapes unrecognizable to us, another where your parents never met, and another where they met under different stars, each world unaware of the rest, each carrying its own sky, and yet it's all one equation, one great wave of being, spreading since the beginning. In mathematical language, physicists call it the universal wave function, but you can imagine it more softly as a vast sea of harmonics, all the possible songs the universe could sing playing at once. Decoherence ensures that each melody becomes private, its own self-contained universe, never mixing back with the rest. The notes are separate now, but they all belong to the same symphony. If you close your eyes, you can almost picture it. Galaxies as eddies in a cosmic ocean, their starlight rippling through nearby branches like reflections trembling across layers of glass. Somewhere, light from a star billions of years old might strike an atom in your eye, while in another world that same photon misses, continuing on forever. A single quantum event, repeated across uncountable realities. It raises a tender question. What does it mean to be small in a universe so wide? Maybe smallness isn't an insult here. Maybe it's a form of belonging. You are part of this grand branching, a local awareness in a structure vast beyond comprehension. Each thought you have, each blink, each decision is another small ripple, another tiny separation of paths that carry you forward. The idea of endless branching might seem cold at first, but it carries a strange warmth too. Because if every outcome exists somewhere, then the universe never wastes anything. No possibility is truly lost. The laughter that might have been, the conversation you never had, the person you could have become, all of them still exist in their own quiet corners of reality. The cosmos is not a gatekeeper. It's a gardener that keeps every seed. Some scientists, like Max Tegmark, tried to organise this cosmic garden into levels. He spoke of level 1 of multiverses, regions of space so far apart that light will never let them meet. Level 2 universes, born from different cosmic inflations with their own physical constants. Level 3 universes, Everett's many worlds, blooming from the same quantum tree. And beyond even that, level 4, the possibility that every consistent mathematical structure exists somewhere as its own reality. It sounds abstract, but you don't need to know the equations to feel the wonder in it. It's a hierarchy not of distance, but of imagination. The deeper we look, the more reality we find. In this picture, your life is a thread woven through a multi-dimensional quilt, one strand among billions, but essential to the pattern. Without your thread, the fabric would be incomplete. It's comforting to think that in some distant branch, your unmade choices found homes of their own. The world where you left something unsaid. The world where you found the courage to say it. The world where you turned a corner and met a friend you never would have known otherwise. And because all these worlds share a common origin, they're not truly separate. They're harmonics of one cosmic instrument. The equation suggests that every split preserves a delicate balance called unitarity, a word that simply means nothing is destroyed, only transformed. In the gentler language of the night, it means that being itself is never wasted. Every note once played continues to echo somewhere. Think of a forest on a calm day. Each leaf catches the wind differently. Some shiver, some stay still, some drift away. Yet all of them share the same air. The many worlds universe is like that forest, each world its own leaf, trembling on its branch, rustling to the same invisible breeze of quantum chance. It might seem far away from daily life, but the connection runs deep. Every photon that warms your skin, every atom in the food you eat, every flicker of thought in your mind is part of this branching process. In that sense, you are the universe knowing itself, a small consciousness nested inside an endless pattern of becoming. When Everett first conceived this idea, he imagined the branching happening everywhere, every instant. Even the cosmic microwave background, the faint radiation left from the Big Bang, could be thought of as the shared afterglow of those early divergences. Its faint hiss, detected by our telescopes, might carry the overlapping songs of countless parallel beginnings. The thought can be dizzying, but also deeply peaceful. Because if everything branches, then even endings are gentle. Nothing truly stops. It just moves beyond where we can follow. In some far-off branch, the stars may already have faded, yet in another, they are still being born. The story never closes, it simply changes pages. As we let that thought settle, we arrive at a question that feels both daring and inevitable. If the universe contains every possibility, then there must be branches where every version of you survives. In some worlds, you may grow old. In others, you may not. But if consciousness always finds itself in the branch where it continues, what does that mean for death itself? Could there be a way, hidden in the mathematics of existence, for awareness to glide endlessly from one surviving branch to another? The physicist Max Tegmark once asked this question, with the unease of a poet touching the edge of infinity. His answer became a thought experiment, both fascinating and terrifying, one that would come to be known as quantum immortality. It's not a promise of eternal life, but a test of how far our understanding of reality can stretch before it snaps. And so, as the starlight fades and the quiet hum of the universe deepens, we step toward this next idea, an experiment that tries to glimpse what it means to live forever in a world that never stops branching. The trail of clues leads us gently into a thought experiment so simple, so absurd, that it feels like something out of a bedtime story for physicists, though the ending is anything but restful. It began, as many strange ideas do, with curiosity and a touch of mischief. Physicist Max Tegmark once imagined a device, not a weapon, but a machine of pure chance. Its workings, he said, would depend entirely on the unpredictable spin of a single particle. Picture this device not as something cruel or dangerous, but as an instrument of rhythm, a machine that clicks once each second. Inside it, a quantum coin is tossed, though not a real coin but a whisper of probability, a particle caught between two possible spins. If the result leans one way, the device makes a soft click, harmless, familiar, steady as a clock. If it leans the other way, it falls silent. Nothing more, nothing less. Now imagine, sitting beside this device, eyes closed, surrounded by stillness. Each second stretches, and then you hear it click. Another breath, another second, click. Time marked not by the turning of hands, but by quantum chance itself. In the many worlds view, every toss of that invisible coin creates two branches of reality, one where you hear the sound, and one where you do not. From your own perspective, you will only ever notice the branches where the clicks continue. You never experience the silence. You simply drift from one surviving moment to the next. Each sound becomes a kind of reassurance, proof that you're still here, still listening. The world where the click stopped fades quietly away, as though it never existed at all. To an outside observer, this seems trivial, just randomness. But to the listener, those continuing clicks might feel like eternity itself, a rhythm that can never quite end. And in this small, harmless image, Tegmark revealed something enormous, the eerie possibility that consciousness, by its very nature, might only ever find itself on the branch where it continues to exist. This idea came to be called quantum immortality. It's a strange phrase, heavy with misunderstanding. It doesn't promise youth or health, or any supernatural survival. It simply suggests that, in a universe where all outcomes occur, there will always be at least one version of you that goes on hearing the clicks. From the inside, you would never experience the silence that marks an ending. The clicks would continue forever, gentle, rhythmic, and unending. To describe this without equations, think of consciousness as a candle flame in a storm. Each gust of wind threatens to extinguish it, yet the universe holds infinite branches, infinite drafts of air. Somewhere, there's always a breeze that spares the flame. In those branches, awareness continues. To the flame, the wind never truly wins. Of course, in the real world, death is not a sudden coin flip. It's a complex, gradual process, the dimming of countless quantum interactions, the fading of the song we call self. But as a metaphor, the clicking device offers something to contemplate. If every quantum event can create new worlds, then perhaps life and death are not opposites, but neighbouring rooms in the same vast house of reality. Still, even as we speak about it softly, there's a chill beneath the idea. Because if you only ever experience the branches where you survive, the experience could become endless. Each survival just another second, another click. No grand immortality, just an unbroken chain of continuations. Close your eyes for a moment and imagine that rhythm. Click, click, click. A sound so steady it begins to blur with the beat of your own heart. You might start to wonder, is this what eternity would sound like? Not trumpets or choirs, but the quiet persistence of survival. But then, as with all experiments of the mind, comes the unease. Tegmark never built such a device, nor did he suggest anyone should. He used it as a mirror, a way to test the limits of our belief in many worlds. Because if the theory is taken seriously, it must include this possibility too. The strange logic of quantum mechanics doesn't flinch, it simply unfolds every path, even the unsettling ones. And there's something profoundly human about our discomfort here. We long for meaning in survival, yet the idea of infinite continuation without rest feels less like a blessing and more like a weight. To live forever, stripped of contrast, might be to forget what living means. Every dawn needs a dusk to make it beautiful. So we step carefully through the thought experiment, treating it not as prophecy, but as philosophy, a reflection on how consciousness might weave through the maze of existence. In that gentle hum of clicks, we can hear the question beating softly beneath. What is it that really dies? The body? The memory? Or merely the particular arrangement of awareness we call me? Maybe the universe doesn't erase us when we fade. It simply changes the melody. Each branch is a new verse, and consciousness, like a refrain, finds its way into the next. It might not be the same song, yet something of its rhythm endures, an echo of continuity across the grand chorus of worlds. If we stretch our imagination a little, we might even see the rhythm of quantum events as the universe's heartbeat. Every time a particle decides between paths, the cosmos breathes in two directions at once. Some of those breaths carry us forward, others drift away unseen. But together, they sustain the living symmetry of all things. In that sense, the click is not just a sound, it's a reminder. Every heartbeat, every inhale, every tiny decision you make is another branch of the same pattern. You are part of that ongoing rhythm, neither separate from it nor above it. The universe is clicking through you, and you through it. Perhaps that's the quiet miracle Tegmark's idea really points toward. Not the fantasy of eternal life, but the realization that the act of being conscious, right now in this moment, is already part of something endless. Every second you exist, the universe continues to branch, ensuring that awareness, somewhere, always survives. If we follow this soft rhythm a little further, the story begins to narrow again, moving from the thought experiment to the man whose work inspired it all. A man who believed the wave never collapses, and who found in that belief a strange kind of comfort. In the next quiet turn of our journey, we'll meet Hugh Everett again, not as a theorist, but as a human being trying to live in a world that may never truly end. The path now carries us toward the man whose quiet, stubborn imagination started all of this. Hugh Everett, the physicist who believed the wave never collapses. In our story so far, he's been a distant name behind equations, a ghostly presence guiding the math. But tonight we meet him as he really was, a man sitting at a cluttered desk, cigarette smoke curling above pages of dense symbols, the hum of a refrigerator blending with the hum of thought. Everett was only 26 when he wrote the idea that would change everything. He wasn't trying to invent parallel universes. He was simply trying to fix a contradiction that had haunted physics for decades. The uneasy boundary between the quantum and the classical, between the uncertain and the certain. His reasoning was clear, almost serene. If the wave function describes the world perfectly, then let it describe all of the world, observers included. No collapse, no exception. Just one continuous unfolding of the universe through time. But ideas, like people, sometimes take time to be understood. When Everett presented his work, the response was cold. Niels Bohr dismissed it as metaphysical fantasy. His professors called it unnecessary. His advisor, John Wheeler, politely urged him to pursue something more practical. Everett left academia soon after, taking a job in defense research. The world moved on, and so did he, at least in this branch of it. In another version of the story, perhaps his paper was celebrated. Perhaps he was given a university chair. Perhaps he watched his theory blossom into mainstream thought. But here, in our world, he became a quiet man with too much brilliance and too few people willing to listen. He carried his idea like a secret flame that no one else seemed to notice. And yet, that flame burned deeply. According to his biographer, Everett once confessed that he believed his interpretation of quantum mechanics guaranteed him a form of immortality. He reasoned that consciousness, whatever it truly is, must always find itself in the branch where it continues to exist. He imagined that, in every moment when death was possible, some other version of himself would survive. In that branch, awareness would simply move forward, unaware of the worlds left behind. There's something hauntingly beautiful about that belief, though it blurs the line between science and faith. It wasn't a boast or a fantasy of eternal youth. It was, in a strange way, an attempt to make peace with reality's strange logic. To say, perhaps consciousness cannot observe its own absence. Perhaps the self is a sequence that never quite stops. Still, it's hard not to feel the irony of his story. Everett, the man who might live forever in theory, lived only 51 years in this world. He smoked constantly, drank heavily, and grew weary of the academic coldness that had exiled his ideas. When he died suddenly of a heart attack in 1982, his ashes were scattered into the air, fitting in a way, for a man who believed in infinite dispersal. But if his theory is true, somewhere in the boundless branches of the universe, another Everett kept breathing that night. Somewhere, he finished his drink, lit another cigarette and kept writing. Maybe he grew old surrounded by students, explaining with gentle patience that the universe doesn't choose, it continues. Maybe he received a call from Stockholm, an invitation to collect a Nobel Prize. And maybe, in countless other worlds, he never found peace at all. Thinking of him that way feels oddly comforting. We can imagine him existing in all those places at once. A scientist afterlife written not in heaven, but in Hilbert space. Though we need no math to feel its poetry, it's the thought that a single human life, once lived, might ripple through the universe forever, its pattern repeated endlessly in the branching waves of time. Everett's theory asks us to see ourselves in that same light. Every decision, every heartbeat, every accident of chance spins off a new world where the story goes differently. But we never feel those divisions, just as Everett never felt himself multiply. Consciousness is local. It rides one current, one moment, one river of time. All the other rivers flow nearby, invisible. When Tegmark later described his quantum click experiment, he was walking in Everett's footsteps, turning an abstract equation into a mirror for the mind. But Tegmark, unlike Everett, added a note of caution. He knew how easily imagination can slip into recklessness. To wonder if you might live forever is one thing. To try to prove it is another. It would be, he said softly, an extremely stupid experiment. That's the paradox at the heart of this story. The math invites speculation, but the humanity behind it warns restraint. Even if there are infinite worlds, we can only inhabit one at a time. The goal is not to chase immortality, but to appreciate the fragile, improbable existence of this branch. This exact one where you're alive, reading, breathing, listening. Perhaps that's what Everett really discovered, though he didn't say it this way. Not a promise of eternal life, but the suggestion that everything, every version of you, every moment, already exists in some vast, timeless structure, that nothing is wasted. That being alive right now is enough to connect you to all of it. Still, there's a melancholy that lingers. It's easy to see Everett as a tragic figure. The man who proved the world would never collapse, yet watched his own hopes collapse around him. The man who imagined infinite survival, yet felt deeply alone in one small corner of it. But in another sense, he embodied the very paradox he studied. His life, like his theory, was both fleeting and infinite, short in time, vast in possibility. So, as you listen tonight, perhaps picture him in another world, somewhere far yet familiar, sitting by a chalkboard, smiling faintly, still trying to explain that the universe never chooses, it only continues. And if, in this world, his voice has faded into the static of history, maybe that's all right. Somewhere, the lecture never ended. Somewhere, it's still going on. Our quiet exploration now turns from Everett's lonely brilliance to a philosopher who followed the thread of his idea even further. Someone who asked what would happen if all causes of death were quantum, and if life itself could slip endlessly into new branches. What he found was both logical and terrible, a vision of immortality that grows heavier, not lighter, the longer it lasts. The trail of thought now passes from the physicist's desk into the philosopher's study, from chalk dust to candlelight. Hugh Everett had opened a door that could never be closed, and many minds stepped through it, some with wonder, others with trembling hesitation. Among them was the philosopher David Lewis, a man with a soft voice and a fierce curiosity for logic. He took Everett's idea of infinite branches and pushed it to its furthest, most unsettling conclusion. Lewis began, as philosophers often do, with a simple question. If every quantum event creates new worlds, and if all causes of death are ultimately quantum, could there always be at least one branch where you survive? He wasn't speaking of heaven or reincarnation. This was reasoning stripped bare, a thought experiment drawn from the strange consistency of physics itself. He imagined what we might call the philosopher's wager. Each time your life teeters on the edge of an accident, illness, or decay, the universe splits. In some branches, you are lost. In others, improbably, you live. From your own perspective, awareness continues only along the threads where you remain alive. You never feel the collapse into non-existence because experience cannot observe its own absence. In other words, from the inside, death never arrives. To Lewis, this wasn't mysticism. It was a logical corollary of the many worlds interpretation. If reality branches at every uncertainty, then somewhere there is always a version of you who breathes again after each disaster. Each moment of survival reinforces the illusion of continuity, the sense that life just keeps going. It sounds almost gentle at first, like a comforting bedtime story told by a careful universe. Don't worry, the cosmos whispers. There will always be another morning. But as Lewis followed the idea further, it turned dark. Because if you never stop experiencing life, then you might also never stop aging. You might survive every catastrophe, every illness, every failing heartbeat, not through miracle, but through the quiet arithmetic of infinity. The candle of consciousness might never go out, but its wax would still melt. Its flame would gutter lower and lower, stretched across endless years. Lewis borrowed a word from literature to describe this haunting state. Struldbrug, from Jonathan Swift's Gulliver's Travels. In that tale, the Struldbrugs are immortal people cursed to grow older forever, their minds fading, their bodies crumbling, their memories turning to dust that never settles. Immortality, stripped of renewal, becomes eternal decay. So the philosopher's wager is not a promise, it's a warning. To win it is to endure forever. To lose it is to end in peace. Lewis understood the cruelty of the logic, yet he couldn't dismiss it. If you truly accept that quantum mechanics allows all outcomes, then this grim persistence follows as naturally as sunrise after night. To make the idea feel less abstract, imagine a candle burning in a dark room. Each flicker of the flame is a moment of chance. Sometimes it wavers, sometimes it brightens, sometimes it almost dies, but never quite. There is always one branch where it survives. Its light thinner each time, but still there. If you were that flame, you would never witness darkness. You would simply burn slower, smaller, stretching the act of being across eternity. It's difficult not to shiver at the thought. Tegmark, who popularised the notion of quantum immortality, admitted that he didn't endorse it as anything more than a mental exercise. He even offered 3 gentle rules to remind us that the story should stay safely in imagination. First, the decision must be truly quantum, governed by chance at the smallest level. Second, the transition from life to death must happen faster than perception, too swift to be felt. And third, it must be genuinely final, no lingering half-states. Only then, he said, could such an experiment test the idea. But he never smiled when he said it. He called it macabre, a word that sounds like a sigh in the mouth. Others, like the philosopher Charles Sevens, argued that even this safeguard fails. Because in the real world, there are no truly instant events. Even the sharpest transition unfolds in time. The branching, he said, happens before the end ever arrives. So both outcomes exist, and you will die in one of them. In truth, the philosopher's wager is less about physics than it is about fear. It asks how we live when confronted with infinite possibility. Would you live differently if you believed there was always another version of you continuing on? Would you take risks, comforted by the idea that somewhere you always survive? Or would that thought weigh on you, as though you could never rest, never close your eyes knowing the story ends? Perhaps that's why this idea feels so haunting. It turns immortality into a mirror for our own attachments. We long for continuation, but we also need closure. We crave safety, yet meaning often comes from fragility, from knowing that every moment could be the last. Without that, even paradise would lose its shine. Lewis understood this paradox deeply. His wager wasn't meant to tempt, but to humble, to remind us that the same logic that gives us infinite worlds also forces us to face what endless life would really mean. To exist forever, yet grow endlessly weary. To see all that you love vanish while you remain. To outlive not just people, but meaning itself. It's a thought that slides quietly from wonder into melancholy. The universe, in its generosity, may offer infinite branches, but not all gifts are kind. There's comfort in knowing that somewhere you might live forever, but there's also comfort in believing that this branch, this one life, is enough, that its limits give it shape, like the frame around a painting. And so we find ourselves again at the edge between science and philosophy, between the dream of immortality and the need for rest. Quantum theory offers both possibilities, endless continuation and graceful endings. Perhaps both are true in their own way. Every life infinite somewhere, but finite here, where meaning blooms precisely because it can fade. As the candle in Lewis's study burns low, its light trembles across the walls. Each flicker is another branch, another you, another version of tomorrow. And yet, all of them share this same soft glow, the warmth of existence, brief or eternal, equally precious in either form. Our story now turns toward the deeper question that underlies all of this. If some worlds carry louder echoes of reality than others, what decides their strength? Why do we find ourselves in this branch, not the next? To answer that, we must listen to the rhythm of probability itself, the quiet music by which reality chooses which notes to play. Our quiet journey now turns from immortality to rhythm, from the dream of endless life to the question of why reality hums to certain patterns more than others. If every possibility exists, why do you find yourself in this one? Why is this branch, the one where you're here, listening to a story under the soft weight of the night, the one you inhabit, rather than one of the countless others where things went slightly differently? Physicists call this puzzle the problem of probability. In Everett's infinite branching universe, all outcomes happen. The equations don't choose, they simply unfold. But then, what does it mean to say one outcome is likely? If everything occurs somewhere, what role is left for chance? The answer, though born in mathematics, can be translated into music. Think of reality as a vast orchestra tuning before a performance. Each instrument, each possible event, produces its own tone. Some tones are strong and resonant, others faint and barely audible. When the symphony begins, you hear the melody that carries the loudest weight. Yet, somewhere behind the curtain, all the other notes still hum in quiet harmony. In quantum mechanics, the Born rule gives a way to describe this loudness. It says that every possibility carries an amplitude, a measure of its intensity, and that the probability of finding the world in that state depends on the square of that amplitude. But rather than thinking of squares and numbers, Imagine this as brightness. The wave function, that great shimmer of existence, glows more brightly in some places than others. The places that shine the most are where the universe is most likely to focus its gaze. In poetic terms, the Born rule tells us that not all possibilities are equal. Some sing louder, some glow more vividly. It's not that the others vanish, they're just softer harmonics in the background of being. To grasp this without any equations, you can picture tossing a handful of pebbles into a still pond. The ripples cross and mingle. Where they overlap in phase, rising and falling together, the waves grow tall. Where they cancel, the surface flattens. The universe behaves like that pond, full of ripples of probability. The crests we see, the worlds that stand out, are those where the waves strengthen each other. The rest fade quietly into interference, still real but hidden. You could also think of it as the dimmer switch on a lamp. Every possibility exists like a room faintly lit, but some are turned up brighter than others. The brighter the glow, the more likely that's the world you'll wake into. Probability isn't about fate, it's about illumination. This picture may sound poetic, but it solves a very real puzzle. It explains why we don't experience the universe as pure chaos. In the sea of possibilities, the waves of higher intensity dominate what we perceive. They don't erase the others, they simply sing loud enough to become our reality. Still, there's something mysterious about this cosmic hierarchy of brightness. What gives one branch more weight than another? Physicists say it's built into the structure of the wave itself, a kind of natural rhythm that governs how the universe divides its attention. But when you step back, it feels deeper than that, almost personal. After all, when you roll a die or flip a coin, you already know that chance hides in every outcome. You feel it in the anticipation before it lands, that brief moment where all possibilities coexist. Then one result emerges, and the others dissolve like morning fog. The Born rule is the universe's way of keeping that moment fair, ensuring that the grand game of chance has balance. But balance doesn't mean predictability. Even the brightest melody contains rests, pauses where silence holds meaning too. The faint branches of possibility still exist, quietly sustaining the harmony. Without them, the music would lose its texture, its uncertainty, its wonder. If you could listen closely enough, perhaps you'd hear it. A cosmic hum layered with every choice, every quantum twitch of matter. The louder harmonics carry you, the worlds where your story continues, while the softer ones remain just out of reach, contributing to the fullness of the whole. And that's the curious beauty of probability. It isn't a limitation, it's a form of grace. It lets the universe express itself in patterns we can live inside. It makes reality playable, like a song with rhythm and measure instead of endless noise. It also reminds us that our experiences as what feels certain, what feels inevitable, are just one line of melody chosen by that cosmic rule. Another listener in another world might hear a different tune altogether. You can even feel this principle in your own life. Think of all the times when outcomes seemed balanced on the edge, when things could have gone one way or another, and somehow they leaned your way. Each of those moments is a gentle expression of the same universal law. It doesn't guarantee safety or fairness, but it gives shape to randomness. It ensures that, in the grand symphony of chance, there's rhythm instead of chaos. In some sense, the Born rule is the heartbeat of the multiverse. It keeps time so the infinite branching doesn't dissolve into static. Each pulse sets the tempo for reality's unfolding, deciding which worlds will hum loud enough to be lived. And maybe that's what it means to be alive in this branch. To exist within one of the loudest notes, to be part of the main melody of the universe, at least for now. Somewhere, fainter harmonics of you hum quietly, each carrying its own life, its own music. You can't hear them, but they add depth to the chord that is existence itself. If we follow that sound a little further, we reach a stranger idea, a philosophical one that asks whether we should ignore the branches that fall silent. David Lewis thought we could. He imagined that when the song ends in one world it doesn't matter, because another continues the tune. But other thinkers, softer, perhaps wiser, weren't so sure. Can we really turn away from the quiet notes of existence and pretend they don't count? Can we measure life only by the music we still hear? The next part of our journey drifts into that question, into the moral and mathematical debate over how to count worlds, how to weigh the branches, and how to listen fairly to the symphony of everything. The trail of our exploration now winds into a quieter chamber of the mind, where mathematics softens into philosophy and numbers become questions about fairness. When physicists talk about probability, they use it to predict. When philosophers talk about it, they use it to understand. Somewhere between those two instincts lies a debate that sounds technical, but beneath it hums something deeply human. How should we count existence itself? In the Everettian view, every possible outcome happens, branching into its own world. Yet not all branches are equally bright. Some carry more of what physicists call measure, a kind of intensity or amplitude that decides how much of the universal wave they occupy. The Born rule tells us how those intensities relate. The larger the amplitude, the louder the note, the more likely you are to find yourself there. But if all these worlds are real, what happens to the branches where awareness fades? What about the ones where you die, or never awaken, or never came to be at all? Should those silent branches still count in the great tally of being? David Lewis thought he had an answer. He proposed what he called, in his logical way, the corrected intensity rule. His idea was simple enough: ignore the branches that no one experiences. If death is oblivion, then there is no consciousness there to care. In calculating the measure of what matters, he said, we should reassign all the weight to the living worlds, the ones that still think, feel, and observe. To put it gently, imagine a choir singing across the universe. Some voices fade mid-song, their echoes disappearing into silence. Lewis suggested that for any listener, those silences don't count. What remains is the continuing harmony of those still singing. In his view, that was not arrogance but logic. The same reasoning that says we can't mourn our own absence because we'll never know it. Yet not everyone agreed. Another philosopher, David Papineau, listened to this argument and shook his head. To him, ignoring the silent voices felt wrong. Why, he asked, should the dead be erased from the equation? Their notes may have stopped, but they were still part of the score. Reality, he argued, doesn't stop existing just because no one hears it. A physicist named David Deutsch went further. He pointed out that Lewis's adjustment wasn't something you could find in the math of quantum theory. It wasn't written in the language of waves or amplitudes. It was an extra assumption, added for comfort, not for truth. When we make decisions, he said, we shouldn't ignore the histories where we are absent. They still exist, even if we no longer walk their paths. Their debate may sound abstract, but it echoes something we all feel in quieter moments. When we lose someone, the world doesn't end, but a note goes missing from the harmony. The melody continues, yet we hear the absence. Lewis wanted to write a theory where that silence doesn't matter. His critics insisted that it does. Both were trying, in their own way, to understand how the universe keeps score. To translate this dispute without the scaffolding of math, picture a long row of mirrors in a dimly lit room. Each mirror reflects you at a slightly different angle, a slightly different moment. Some reflections glow brightly, others are faint, almost gone. Lewis's logic tells you to focus only on the lit mirrors, the ones still shining back at you. The darker reflections, he says, no longer belong to your experience, so they fall away. But Papineau and Deutsch would tell you to keep them all. The dim ones too are part of the truth. The fullness of reality includes even the reflections you can no longer see. You might sense here how mathematics and morality quietly merge. Counting worlds is also counting meaning. Do we value only the living branches because they're the ones that can care? Or do we include the silent ones acknowledging that existence is larger than consciousness. When we translate these ideas into human feeling, they start to sound familiar. Every day, in small ways, we do the same kind of counting. We choose which memories to revisit, which dreams to chase, which regrets to let fade. We decide, moment by moment, which parts of ourselves still exist in the story we tell about who we are. In that way, we are each living our own corrected intensity rule, weighting some branches of our life more heavily than others. And yet, there's humility hidden in the physics. Even the brightest worlds, the ones we inhabit, are just ripples in the grand sea of possibility. The Born Rule, softly interpreted, says that the universe is fair but not sentimental. It doesn't play favourites. The loudness of a branch isn't moral, it's rhythmic. The same waves that amplify your world also create 1,000 others where you never came to be. Perhaps that's why this debate feels less like a scientific quarrel and more like a meditation. Lewis's impulse to count only living branches is, at its core, an attempt to find comfort in the infinite. His opponent's refusal to erase the silent ones is an attempt to honour the full depth of being. Both positions are reflections of how humans face impermanence, by trying to decide what still counts when the song ends. So, if you find this conversation abstract, bring it closer. Think of a candle standing before a row of mirrors. The nearer mirrors blaze with clear reflections, the ones farther away shimmer faintly. Together, they make a corridor of light that seems to stretch forever. You are the candle, luminous, fleeting, reflected endlessly across the surfaces of reality. Some reflections fade sooner, others linger longer, but none are truly gone. They remain in the structure of light itself, even when no one is looking. Perhaps the universe too is lined with such mirrors, each reflecting a different version of itself, each contributing some fraction of the total glow. If one reflection dims, another brightens. The balance remains. That, in essence, is the meaning of measure. Not weight, but balance. Not preference, but harmony. And if that is true, then perhaps we don't need to decide which branches matter most. The song of existence includes them all, even the silent verses. We don't need to erase the darkness to appreciate the light. We only need to understand that both shape the music. As we drift onward, the conversation becomes quieter still. We've spoken of branching and measure, of loud and soft realities. But what about the spaces between? What about the moments when awareness dims, when you sleep, or lose consciousness, or slip into dreams? Are those moments small deaths, or simply intervals between songs? If reality is always branching, what happens when your mind isn't there to notice? The next part of our journey takes us into that soft frontier, into sleep and dreaming, and the invisible branches where consciousness closes its eyes but the universe continues to hum. Our quiet exploration now drifts towards something everyone knows intimately but few ever think about, the way awareness itself fades and returns. Each night, when you fall asleep, the world seems to dissolve. Your body lies still, your thoughts scatter like leaves in water, and for a while there's nothing, no story, no self, no you. Then, without effort, morning comes, and consciousness reassembles as if it had only paused. But where did it go in between? The physicist and philosopher Anthony Aguirre once wondered if sleep might offer a small window into the mystery of quantum existence. Not as a scientific proof, but as a metaphor, a way to understand how consciousness might weave through the branches of reality. When you fall asleep, your awareness disappears from one storyline, yet the world keeps moving, your body keeps breathing, and somewhere in that quiet, new patterns of mind begin to form. You awaken, not as a new person, but as a continuation of the one who closed their eyes. Now imagine the many worlds universe through that same lens. Each quantum event, Every flicker of possibility creates new branches of existence. In some of those branches, you drift into sleep. In others, perhaps you stay awake a moment longer, or dream a different dream, or never wake at all. Consciousness, like the body during sleep, slips gently between these possibilities, always finding itself where awareness continues. If that's true, then falling asleep might not be a tiny death, as poets sometimes say, but a quiet rehearsal for the quantum rhythm of being. Each time you surrender to darkness, you're letting go of one version of yourself and gliding into another. It feels seamless, because it is. The mind never witnesses its own absence. It only ever wakes up again, somewhere. You can feel this continuity in the soft moment just before waking, when your dreams begin to mix with the shapes of your room. The brain stitches two realities together, the one made of neurons and the one made of stories. For a heartbeat, you are both the dreamer and the observer, both in the world and outside it. And then, just as gently, the choice is made. You open your eyes, and the branch you call today becomes the one that endures. In physics, there's a term called self-locating uncertainty. The idea that before you measure, before you see, you don't know which branch of the universe you're in. But once you look, the uncertainty ends. You find yourself in one world, one version of reality, and everything else fades into the background. You don't experience the other branches where you stayed asleep a little longer, or never woke up at all. To you, they are gone. Yet to the universe, they continue, silent and complete. This isn't magic or mysticism, it's the logical consequence of a world that never stops branching. But it's also a strangely comforting thought. It means that every awakening is a small miracle, a rediscovery of yourself in a new thread of being. Each morning you could say, the universe chooses to keep you, and in that way, quantum immortality and sleep share a kind of poetry. Both suggest that consciousness doesn't experience its own ending. You close your eyes, and then, without knowing how, you find yourself awake again, somewhere, sometime. The continuity feels unbroken. The branches where you didn't wake are as unreachable as forgotten dreams. To understand this softly, imagine a lighthouse turning in the dark. Its beams sweep slowly across the waves, lighting one patch of sea at a time. The light doesn't vanish between rotations, it only shines elsewhere. Consciousness might be like that, not fixed to one location, but always illuminating the next moment of awareness, wherever it happens to be. When Aguirre spoke of this, he wasn't trying to claim that dreams prove the multiverse. He meant something subtler, that our experience of existence already carries the texture of branching. We are constantly fading and returning, slipping in and out of focus, never noticing the invisible gaps in our story. Life is a sequence of awakenings, each one unaware of the countless versions that never stirred. In those moments when you wake in the middle of the night, disoriented and unsure where you are, you've touched that boundary. For a second, you exist between branches, one where you are dreaming, one where you're awake, both blending at the seam. You feel a quiet unease because your mind hasn't yet chosen which world it belongs to. Then, with a breath, it decides. The dream dissolves, and the room returns. Perhaps that's why sleep feels so restorative. It isn't just rest, it's renewal. It allows consciousness to rearrange itself, to smooth over the frayed edges of reality. Each cycle of sleep is like a gentle reset, a rejoining with the rhythm of the cosmos. In that sense, you might say that sleep is the universe's way of reminding you how to let go, safely, peacefully, without fear. And maybe that's what true immortality in any sense would feel like. Not endless waking, but endless continuity. A flow from one state of awareness to another, with no memory of the pauses in between. You wouldn't notice the transitions. You would only ever find yourself existing, again and again, in the branches where consciousness persists. Still, there's something tender about the idea that some parts of existence continue quietly without us. The world you leave behind when you fall asleep doesn't vanish, it simply goes on without your awareness. The same may be true for the countless universes where your story diverged. Their silence isn't emptiness, it's completion. Each world continues its own melody, even when you're not there to hear it. If you step outside under the night sky, you can feel that same peace. The stars above you are ancient, there, light travelling through uncountable branches of reality. Some of that light reaches you now, some never will. Yet every photon follows its path, just as you follow yours, each illuminating a different corner of possibility. And so, perhaps immortality isn't about defying death, but about recognizing the quiet persistence of being, the way awareness, like a traveller in fog, always finds a way forward. When you next fall asleep, think of it not as an ending, but as a soft rehearsal for the universe's own rhythm of fading and returning. You'll wake again, as you always do, in one of the branches where light still falls gently through the window, and morning once again remembers your name. From here, our journey turns inward again, away from the infinite branching of universes toward the delicate question of what it means to be you. Physics can split worlds without hesitation, but the mind hesitates because the self feels indivisible. It feels like one unbroken thread, not something that can be copied, remade, or shared. Yet when we follow that thread into the quantum world, it begins to fray, then multiply, then vanish into mist. There's a story philosophers love to tell, borrowed from science fiction but sharper than any equation. Imagine a starship travelling far from Earth. On board, there's a machine designed to teleport people, an elegant marvel of technology. You step inside. The machine scans every atom of your body, records the exact arrangement of particles, and sends that information as a beam of light to another chamber miles away. There, the pattern is reassembled, every cell, every memory, every heartbeat, until the person who emerges looks, feels, and thinks exactly like you. The transporter hums quietly, the light fades, and suddenly, there you are, alive and whole, stepping out of the chamber. You look down at your hands, wiggle your fingers, speak your name, and feel absolutely certain, I made it. But then, someone whispers, the original body wasn't destroyed in the process. It still stands in the first chamber, breathing, blinking, just as you were a moment ago. Two of you now exist, each convinced they are the original, each carrying the same memories, the same story up until that instant. One will continue the mission on the ship, the other will stay behind. Which one is really you? It's not a trick question. It's a mirror held up to identity itself. Both versions remember being you. Both love the same people, carry the same scars, and dream the same dreams. From their own perspectives, each has perfect continuity. To the copy, the transfer worked. To the original, something strange has happened. Someone else, somewhere, now believes themselves to be you. In quantum language, this resembles branching. A single pattern of information has split into two, each equally real, each continuing its own story. But when told as a story of selfhood, it's no longer abstract. It's intimate, unsettling, even tender. It's like two echoes of one voice, each convinced they sang first. If you look at it scientifically, there's no contradiction. Both versions exist. Both are valid continuations of the same data. Yet to consciousness, it feels impossible. The mind resists duplication. It insists on being singular, indivisible, a flame, not a reflection. But physics seems to suggest otherwise. Perhaps identity isn't a fixed point but a process, like a wave that keeps its shape even as the water beneath it changes. The atoms in your body are replaced every few years. Your memories evolve, your opinions shift, your cells divide. Yet through all this, you feel continuous. The self is not the matter, it's the pattern. and patterns, as Everett might remind us, can exist in many copies at once. Still, the thought leaves a chill. You might survive perfectly in one branch, but somewhere else, another you continues, equally vivid, equally alive. It's comforting to know that the story never ends, but unsettling to realise that your story is no longer uniquely yours. Each copy thinks of itself as the continuation, never knowing it shares the title. To soften the unease, think of the self not as a single flame, but as a constellation. Each version of you is a star in that constellation, separate points of light, yet forming one recognisable shape. The pattern is the self. The individual stars are its moments in time. None can claim to be the original, because all are part of the same picture, drawn across different skies. In this way, the transporter paradox is not a riddle about technology, but a meditation on awareness. It whispers that continuity is not about matter or memory, but about perspective. The I that says I am is always local, anchored to one branch, one instant, one heartbeat of time. The rest of you, spread across countless realities, goes on quietly elsewhere, never aware of the others. If that feels lonely, let it be gently reframed. You're not a fragment separated from your other selves. You are the moment they converge. All the versions of you that ever were and all those that will be meet here in this single flicker of awareness. The present is the only place where infinity touches itself. There's an old thought in Buddhist philosophy that says the self is like a river, always flowing, never the same water twice, yet somehow still called by one name. The quantum world agrees, though it whispers it differently. It says the river doesn't just flow, it divides endlessly into smaller streams. Each carries the same source water, each reflecting the same sun, each believing it is the only river, and maybe, in its own way, it is. So, what does that mean for you sitting here, listening, in one small branch of one vast universe? It means that your sense of self, this warm, personal continuity, is both precious and illusory. It's a song that replays in different keys across infinite worlds. In one, the melody carries on. In another, it fades. But no single note can claim the song as its own. It's tempting to see this as tragic, as if individuality is lost in the grand machinery of physics. But maybe it's the opposite. Maybe it's a kind of immortality richer than any we imagined. Not the survival of a body or memory, but the endless recreation of the pattern that makes you you. A pattern so persistent, so elegant, that the universe cannot stop repeating it. If you could stand outside of time and see all yourselves at once, it wouldn't look like duplication, it would look like motion, like a dance of countless reflections, each taking a step that carries the whole pattern forward. And perhaps that's what we are. Steps in a dance, notes in a chord, echoes in an endless hall of mirrors. Each moment of awareness feels singular, but together they form the harmony of being. As this thought settles, the story of the transporter fades back into stillness. The two versions of you step away from their chambers, each walking their separate path, each believing themselves to be the one who continued. Neither is wrong. Both are true, and as the hum of that imagined machine fades into the distance, we're left with the same question the universe seems to ask every time it branches. When everything that can be you is you, what part of you truly remains unique? If we follow this question further, we reach a gentle counterpoint or the voice of physicist Sean Carroll, who reminds us that even in a universe of infinite continuations, meaning doesn't dissolve, death, he says softly, still matters, and care, the simple act of valuing this fragile moment, matters most of all. If we follow the thread of the story a little farther, it brings us to a quieter voice in the modern conversation, that of the physicist Sean Carroll. He's a man who loves the elegance of mathematics, yet never forgets that equations describe people as well as particles. When others began to spin fantasies of endless quantum survival, he paused and asked a gentler question. Even if consciousness never feels its own end, does that make death meaningless? Carroll's answer was soft but firm. The fact that you can't feel death, he said, doesn't mean it isn't real. You can imagine him saying it not as a scolding, but as a reminder, like a teacher turning down the lights after class, making sure the lesson settles before everyone goes home. He meant that awareness is not the whole of existence. Physics may tell us that somewhere, in some unreachable branch, another you continues. But the people who love this, you will still feel your absence here. The conversations will still stop mid-sentence. The chair will stay empty. The echo of your laugh will fade. The many worlds interpretation may give the cosmos endless chances, yet meaning lives locally, in the warmth between finite hearts. Carroll often describes physics as a kind of humility practice. It shows us that we're not the centre of the story, not in space, not in time, not even in probability. But it also teaches that this small corner we inhabit still matters because it's the one we can touch. Even in a multiverse, he once wrote, we only ever live one life. You could think of it the way you think of sunlight through a window. The light may come from a star that burns for billions of years, shared by uncountable worlds. But the warmth that reaches your skin exists only in this single beam, in this instant. You wouldn't trade it for the abstract promise that somewhere another beam falls on another version of you. This one is enough. There's an ethical heartbeat hidden in that idea. In the thought experiments about quantum immortality, death becomes just another branching event, something consciousness skips over on its way to another continuation. But Carroll reminds us that what gives life value is precisely its boundary. We avoid harm not because we fear nothingness, but because we cherish connection. The desire to live is not superstition. It's gratitude for the fragile, luminous intersection of matter and mind that makes caring possible. If you look closely, this is not so different from what the equations themselves say. The universe evolves according to what physicists call unitary laws. Information conserved, nothing truly lost. Yet, when translated into the language of human life, that conservation doesn't erase grief. It just means that traces of our existence ripple onward, in starlight, in memory, in influence, in love. The wave of being continues, but each crest still falls. To illustrate it gently, imagine throwing a pebble into a pond. The ripples spread in perfect circles, fading as they travel. The pond never loses the energy you gave it. It just redistributes it. Your life works the same way. Every kindness, every word, every act of care sends a pattern outward. The ripples will reach far beyond sight, maybe into other branches of the universe itself. But the pebble, the moment of living, happens only once. Carroll's point isn't to deny the wonder of many worlds. He accepts its possibility with open curiosity. He simply refuses to let that infinity cheapen the present. In his view, acknowledging mortality doesn't diminish the universe's magic, it grounds it. The night sky is not less beautiful because it will one day fade. It's beautiful because it shines now. There's also a kind of tenderness in the way Carroll speaks about purpose. He says that meaning doesn't have to come from survival, it comes from continuity of influence. You're not eternal consciousness leaping from branch to branch. You're a pattern that gives warmth to this slice of space-time, a temporary alignment of atoms that happens to feel and care. That, he says, is miracle enough. This may sound philosophical, but it's also practical. When you hold someone's hand, when you offer a kind word, when you decide to make something instead of nothing, you're asserting that this branch matters. You're shaping probability with compassion, not mathematically, but emotionally. You can't alter the cosmic equations, but you can fill the outcomes you inhabit with meaning. There's comfort in that. If Everett's universe is the endless book of possibilities, Carroll's reminder is that you only ever get to read one line at a time. And that line, the one you're living right now, is precious precisely because it's fleeting. Think again of the transporter from our previous story. Two versions of you step out, each sure they're real. From the outside, both are identical. But from within, each lives a distinct set of relationships, a unique web of care. If one of them loses a friend, that grief is real in that branch. It can't be soothed by the knowledge that somewhere else, both still laugh together. Meaning can't be outsourced to parallel worlds. It must be lived where it happens. That's the heart of Carroll's compassion. He believes physics should make us humble, but never indifferent. The vastness of the universe should deepen our empathy, not dissolve it. To him, the awareness that every choice may spawn new worlds doesn't free us from responsibility. It amplifies it. Every action echoes through possibility, shaping the harmony of the multiverse in small, human tones. So even if death is, in some ultimate sense, only a change of branch, we still mourn, still love, still try to protect one another. We do it because the measure of being human isn't survival, it's connection. You can feel that truth in simple things. The way you linger over a goodbye, the way you smile at a stranger, the way you pause to listen to the wind as if it might remember your name. These gestures don't deny physics, they complete it. They remind the universe why consciousness matters at all. Perhaps that's what Carroll means when he says death still matters. Not that it ends everything, but that it gives everything weight. A song with no final note would have no melody. A story with no ending would have no shape. Mortality gives meaning the way gravity gives structure to stars. It holds the light together long enough to shine. And as we linger on that thought, the question of identity transforms into something quieter. Maybe we don't need to know which version of us continues, or in how many worlds. Maybe the answer is simpler. Meaning belongs to the version that loves, right here, right now. If we follow that soft realization a little further, we'll meet others who have pondered the same question from different angles. The scientists and thinkers who try to define what you really means in a universe that never stops dividing. Their answers range from comforting to unsettling, yet each brings us closer to the gentle mystery at the centre of it all: time. Want fives. From here, our journey drifts toward the oldest question hidden inside all the others, the one that sits quietly behind the equations and the thought experiments. What makes you, you? When a physicist looks at reality, they see fields and waves, probabilities and patterns. But the mystery of identity lives in something softer, more intimate. The feeling of being a particular person in a sea of possibilities. It's strange, isn't it? We can speak about quantum immortality, the splitting of universes, the endless copies of ourselves scattered across existence. But even now, only one version of you feels like the real one. This version. This breath, this heartbeat, the you who's listening at this exact moment. All the others, if they exist, feel distant, unreachable, dreamlike. That tension between physics and feeling has fascinated many thinkers. The physicist Brian Greene, whose mind is always halfway between the stars and the soul, once said that to truly grasp what the universe is, we might have to broaden our idea of the self. You, he suggested, are not just one of your versions. You are the sum of them all. Every choice, every path, every possible outcome is part of the larger pattern of what it means to be you. The self, in that view, is not a point in space, but a constellation of experiences scattered across time and possibility. It's a beautiful idea, to think of yourself not as a single flame, but as a cluster of lights twinkling in the cosmic dark. It gives comfort in a way. Even if one star fades, the constellation remains. Some part of you continues somewhere, tracing a different arc of life, carrying the same seed of awareness that bloomed here tonight. But not everyone agrees. The physicist Lev Vaidman, who works daily with the mathematics of the many worlds interpretation, takes a more pragmatic view. He sees there are many versions of himself, many Levs, but each belongs only to its own branch. Another I, he once wrote, is meaningless. To him, each branch is self-contained, sealed off by decoherence. The others are not ghosts or fragments of you. They are other people who simply happen to share your history until the moment of divergence. From then on, they are as separate as strangers passing in the street. There's something quietly humbling about that view. It reminds us that individuality, even if it repeats infinitely, remains local. Your consciousness doesn't hop between worlds. It grows where it's planted. Each version of you lives its life, feels its own joys and sorrows, makes its own choices. None of them can claim to be the real you, yet each one is as real as any could be. And then there's David Wallace, a philosopher of physics who tries to step between these two extremes. He agrees that all branches exist, but argues that the concept of the self may not survive branching in the way we imagine. He says that identity, as we use it, may dissolve under the weight of multiplicity. In the language of thought, it's like realizing the word you doesn't refer to a single being, but to an ongoing pattern that changes shape every moment. To translate that into something gentler, imagine the ocean on a quiet evening. From the shore, you can point to a wave and call it by name. That one, right there. It has a crest, a path, a rhythm. But you also know it isn't truly separate. The water that forms it was part of other waves before and will join others again. The identity of the wave is real for a time, but it's also temporary, a structure held together by motion. Maybe you're like that too, a standing pattern in the flow of existence. For a moment, the pattern is stable enough to think, to remember, to say, I am. Then, slowly it changes, recombines, disperses. The particles in your body move on, the memories fade, and the pattern becomes part of something new. Yet for that brief shimmer of time, you are entirely, undeniably real. If this sounds abstract, you can feel it in simple ways. The person you were 10 years ago, or even last year, feels both familiar and distant. You remember their thoughts, but you wouldn't make the same choices now. The pattern has shifted. The continuity between past and present selves is like a bridge made of music. The melody connects, but the notes are always new. From this view, physics doesn't destroy identity. It reveals its texture. It shows that being isn't a solid statue carved once and forever. It's a dance of molecules, a flowing field of awareness that keeps reassembling itself. The you that exists in each branch of the universe is just another verse of the same song, each one slightly different, yet still part of the whole. This realization doesn't make you less real. If anything, it deepens your reality. You're not fragile because you change. You're beautiful because you do. Each version of you across time, space, and possibility is a variation on a theme the universe keeps rediscovering over and over in every breath and heartbeat. It's easy to mistake that multiplicity for loss. The thought that there might be countless versions of you all beyond reach can feel lonely, but it doesn't have to. You can also see it as connection, a reminder that you're never truly singular, but part of something vast and continuous. Like a wave that breaks into foam yet remains part of the sea, you are both momentary and eternal. Perhaps that's what identity really is. Not an object or an essence, but a process, a rhythm, a shape that holds long enough for experience to unfold. In that sense, you is not a noun but a verb, not a fixed point but a pattern of attention, an eddy in the river of the universe swirling for a while before joining the current again. If physics tells us that everything changes, then perhaps meaning lies not in resisting that truth, but in flowing with it. To exist is to be temporary, and to be temporary is to be miraculous. Because for a moment the universe noticed itself and called it you. And so we end this part of the journey not with an answer, but with an opening. If identity is a pattern, then the universe is an artist still at work, painting variations of self across an infinite canvas. And if the self is a wave that keeps rearranging, then every branch, every life, every version of you adds another brushstroke to the same, unfinished masterpiece. But what happens when two truths about that masterpiece collide? When physics and philosophy reach the edge of what they can explain, and we're left staring into paradox itself? As we follow the path onward, the next turn in our journey carries us to that threshold, to the strange mirror where the mind and the cosmos reflect each other, each trying to understand what the other really means. From here, the story turns darker and slower, like a piece of music descending into its final notes. We've wandered through the branching of worlds, through the splitting of the self, and through the shimmer of possibility that physics suggests might underlie everything. Yet even the most elegant ideas eventually meet a boundary, a horizon beyond which clarity begins to bend. In science, one of those horizons is the black hole. In philosophy, it might be the mind, and the two are more alike than they first appear. A black hole begins when a star runs out of ways to hold itself together. Gravity wins. The light that once spilled freely from its surface is pulled inward until even brightness cannot escape. What remains is not absence, but density, an object so compact that space and time themselves bow around it. From far away, you see its boundary, the event horizon, the line past which no signal returns. Physicists once thought that whatever fell into a black hole was gone forever, its information erased from the universe. But then they realized something unsettling. The equations that govern matter, the same gentle rules that describe waves, particles, and even you, refuse to allow true erasure. Information, they say, must be conserved. Nothing can be perfectly lost. It can only change form. So a paradox appeared. If black holes really erase information, then physics, in its most basic sense, breaks. Yet if they somehow preserve it, where does that information go? Does it hide within the black hole? Does it escape, encoded in faint radiation at the edges? Does it smear across the horizon, stretched thin but never destroyed? No one can quite agree. Two truths stand facing each other, both supported by mathematics, both seemingly right, yet both cannot be right at once. The black hole became a mirror of our own understanding. We can see the edges of the mystery, but never cross them. Light bends, and so does knowledge. The closer we look, the less sure we become of what knowing even means. And perhaps that's not a failure of science, but its most honest moment. The horizon isn't a wall, it's a reflection of limitation. It's the place where the universe looks back and whispers, "This far and no farther." You can translate that into the language of the mind just as easily. The human self, too, has an event horizon. Beyond a certain point, you can't retrieve the things that fall inward. Forgotten dreams, lost memories, lives that diverged from yours. Somewhere inside you, information gathers in silence, compacted into something like a singularity of feeling. You can't access it, but you sense it. That deep gravity of experience pulling everything toward meaning. The philosopher Nick Bostrom once described consciousness as the universe waking up to itself. If that's true, then maybe a black hole is what happens when awareness turns too far inward, when reflection collapses into itself so completely that no light escapes. And yet, even there, something remains. Stephen Hawking, who spent decades studying these invisible giants, discovered that black holes are not entirely silent. They emit faint radiation, tiny pulses of energy leaking back into the cosmos. In poetic terms, it's as if even the most consuming darkness cannot help but hum softly to the universe, telling it, "I'm still here." You can imagine your own mind that way. Thoughts fall in, forgotten, buried. Yet some part of them always radiates outward, in gestures, in laughter, in the small ripples you leave behind in others. The self absorbs, but it also shines. And maybe that's what consciousness is, a balance between the inward pull of understanding and the outward glow of expression. If you look at the equations that describe black holes, though we'll keep them hidden tonight, you'd find something elegant. The surface area of the event horizon corresponds to the amount of information it contains. The larger the horizon, the more information is preserved, encoded, remembered. It's as though every particle that falls in leaves its mark on the edge, written in a language we can't yet read. When you think about it, the mind feels similar. Every memory, every experience leaves a faint trace at the boundary of awareness. Even if you forget the details, the outline remains. You may not recall every word of a song you loved, but you still remember how it made you feel. The pattern stays, etched along the edges of consciousness like light around a horizon. This parallel between the physics of black holes and the metaphysics of mind reminds us that our search for meaning often mirrors the universe's search for order. We are not separate from the cosmos. We are made of the same equations, the same mystery. Our inability to know everything isn't a defect. It's the proof that we belong to something larger than comprehension. Think of it like this. When you look at a distant star through a telescope, like you see left that star millions of years ago, you're seeing a version of it that no longer exists, yet the image is real. The universe lets you glimpse the past but never touch it. The same is true of thought. Every memory is starlight from a former self, reaching you across time. You see it, you feel it, but you can never return to where it came from. And still, that distance is what gives beauty its shape. The unreachable horizon, the unanswerable paradox. These are the contours that make wonder possible. If knowledge were infinite, awe would have no place to live. So perhaps the lesson of the black hole isn't about loss at all. Perhaps it's a meditation on humility, a reminder that every truth casts a shadow. Every equation bends under the weight of reality. Even the universe doesn't have all the answers. It keeps some secrets folded deep within itself, not out of cruelty, but out of poetry. The physicist Kip Thorne once wrote that studying black holes felt like listening to the heartbeat of the cosmos. Maybe understanding the mind is the same, hearing the soft pulse of being, knowing it's there even when you can't see it. And as we stand here, on the edge of both horizons, the cosmic and the human, it's worth pausing to listen. The silence between stars, the silence between thoughts, they're not empty. They're full of everything we can't yet understand. If we follow that silence a little longer, we'll find ourselves at the final boundary, the place where physics gives way entirely to philosophy, where certainty melts into wonder, and we begin to ask not what the universe is, but why it feels so beautiful to not fully know. As we drift further into this quiet corner of the cosmos, the conversation itself begins to slow. The air feels different here, lighter but deeper, as though we've stepped into a space where thought no longer needs to hurry. This is the place where physics meets philosophy, where knowledge bends toward humility, and where the search for truth becomes something softer, more like listening than explaining. Every field of science has its frontier, its edge where the known fades into questions. For physics, that edge is quantum reality, the world of trembling probabilities and invisible connections. For philosophy, it's consciousness, the mystery of experience, the sense of I that looks out from behind every pair of eyes. The two frontiers meet like two shores across a narrow sea, both reflecting the same starlight, both trying to understand what they're seeing. When equations meet experience, something gives way. The symbols that describe particles spinning, waves colliding, probabilities collapsing, they can take us astonishingly far. They've built lasers, computers, telescopes, all from patterns drawn in chalk and thought. But when those same equations are asked to describe awareness, or meaning, or love, they begin to hesitate. The mathematics stares back at us and says, "This part you must feel, not calculate." It's tempting to see that as failure, but perhaps it's simply the universe setting a boundary, like the event horizon we visited a moment ago, a place where light bends into wonder. Beyond that point, science becomes poetry. The physicist Anthony Aguirre once described this moment beautifully. He said that ideas like quantum immortality, these strange thought experiments where consciousness slips forever through branching worlds, aren't really predictions. They are tests of the mind's logic. They push reason to its limit until it folds back on itself and asks, is this where understanding ends, or just where it changes shape? In that sense, quantum immortality may not be an answer, but a mirror. It reflects how far we're willing to stretch our faith in logic, and how quietly we resist the parts of existence that logic cannot touch. It shows that even the most rigorous science carries a trace of myth, not in the sense of falsehood, but in the sense of story. Humans make meaning the way stars make light. We can't help it. If you look closely, every great scientific idea was once a myth in disguise. Atoms were once indivisible seeds. Gravity was the Earth's love for the moon. Quantum mechanics began as a story about light behaving like both a wave and a particle, refusing to choose. We tell these tales to make peace with paradox until the language of mathematics can catch up. And even when it does, the story remains a quiet echo of how we learn to see. That's why, when we talk about multiverses or immortality or consciousness, the goal isn't certainty, it's connection. It's the act of reaching into mystery and saying, I want to understand. Science isn't wrong when it fails to answer everything. It's simply honest about being unfinished. The equations we write are like lullabies we hum to ourselves in the dark, not to explain away the night, but to make it feel a little less lonely. And maybe that's what the whole journey through quantum ideas has been about, not proving whether you live forever or how many worlds exist, but remembering that curiosity itself is a form of love. To ask questions about the universe is to confess that you care about it, that you want to be closer to the truth, even if it forever recedes like a star just beyond reach. The philosopher William James once said that our science is a drop, our ignorance an ocean. It sounds humbling, but there's comfort in that image too. The drop shines precisely because it reflects the ocean. The little we know gains meaning from all we do not. Perhaps that's why the universe allows us to know just enough, to build, to wonder, to hope, but not enough to end the story. There must always be another mystery waiting, another equation incomplete, another night sky to gaze into. If everything were known, existence would lose its texture. It's the unknown that gives life its depth. In that way, uncertainty isn't our enemy. It's our companion. It's what lets discovery stay alive. Every time we solve a puzzle, we uncover two more. Every answer opens a new question. This endless unfolding isn't a flaw in reality. It's its rhythm, the heartbeat of knowledge itself. So when people ask whether quantum immortality is true, or whether consciousness truly survives, perhaps the more meaningful question is simpler. Why do we care? Why does the thought of infinity stir both comfort and fear? Maybe because deep down we sense that understanding itself is the only kind of eternity we're meant to experience, an eternity made not of years, but of wonder. If we translate that feeling into everyday language, it's like walking through fog at dawn. You can only see a few steps ahead, but each step reveals the next. The world doesn't need to be fully visible for it to be beautiful. Knowing that the fog hides more than it shows doesn't make the journey pointless. It makes it alive. And maybe that's where science and philosophy truly meet, not in their conclusions, but in their shared humility. Both stand at the edge of the unknown and whisper the same thing. How extraordinary that we are here at all. You can feel that humility in your own life, in moments so ordinary they slip past unnoticed, when you pause before saying something kind, when you watch the way light moves across a wall, when you breathe deeply without needing a reason. Those small moments are where knowledge ends and awareness begins. They're the living proof that consciousness doesn't need infinity to feel vast. So let's not rush to close the question. Let's leave it open, the way the universe leaves everything open, a quiet invitation to keep wondering. The meaning of life may not be hidden in the mathematics of multiverses or the logic of survival. It may simply be this: to keep asking, to keep noticing, to keep being astonished that anything exists at all. And as we near the end of this long journey through possibility and paradox, it's time to return gently to the human story, to the fragile branch of reality where kindness still matters, where choice still changes everything, and where one calm decision can shape the future of an entire world. The path now carries us gently back from the horizon of ideas to the familiar ground of human stories, the kind made not of equations or paradoxes, but of choices. Every great theory about the universe eventually bends back toward this question. What do we do with it? If there were infinite worlds, infinite versions of us, infinite outcomes, then every act of kindness or cruelty, every word we speak still matters. Because this is the branch where it happens. To understand that in a way that feels real, not abstract, let's go back to a moment in history when the world itself teetered, on the edge of annihilation, a moment that reminds us how fragile every branch of reality can be. It was the year 1962, at the height of the Cuban Missile Crisis. The seas were tense with nuclear-armed submarines, each carrying enough firepower to erase cities in seconds. On one of those submarines, deep beneath the waves of the Atlantic, a man named Vasily Arkhipov faced a decision that could have ended our world. The submarine he served on, B-59, had lost contact with Moscow. Surrounded by American ships dropping practice depth charges, the crew believed war had already begun. The captain, shaken and exhausted, ordered the launch of a nuclear torpedo. It required the consent of 3 officers. 2 agreed. The third, Arkhipov, refused. He argued that they didn't know for sure, that launching could trigger a global catastrophe, that it was worth waiting, even in darkness, even in fear. The captain shouted, the temperature rose past 100 degrees Fahrenheit, and oxygen ran low. But Arkhipov stayed calm. He said no. He held the key in his hand and chose restraint. In that moment, every possible branch of history hovered in silence. One where the oceans turned to fire, one where the skies burned, and one, the one we live in, where nothing happened. The world continued. People fell in love. Children were born. Music was written. The quiet hum of existence went on. That's the branch we chose together. Or, more precisely, the branch that Vasily Arkhipov chose for all of us. He never became famous during his lifetime. He never called himself a hero. He just believed that uncertainty was worth living through. He trusted that patience could still hold the world together. If Everett's many worlds interpretation is true, then there are versions of reality where Arkhipov didn't say no, where war began, where Earth became silent dust. But those are not the worlds we know. We inhabit the fragile one, the improbable one, the quiet survivor. We live inside the mercy of a single human decision. That thought can sound frightening, but it's also a kind of grace. It means that history itself may be a tapestry woven from countless moments of restraint, of courage, of compassion. The physics of the universe may be deterministic, but the measure of reality, the weight of the branches that continue, depends on choices like his. You could say that Arkhipav's refusal was a kind of quantum act. Out of all possible paths, he strengthened the amplitude of the one where humanity endured. The rest faded into faint harmonics, Still part of the universal song, but far quieter. What remains is the world that wakes each morning, still intact, still capable of dreaming. When you think of it that way, every decision becomes a kind of experiment. Every gesture of kindness, every pause before anger, every act of forgiveness may tilt the balance toward a gentler branch. It doesn't have to be cosmic to matter. Even the smallest acts ripple outward, weaving the rhythm of what becomes real. Sometimes it's easy to forget that, to feel powerless in the face of vastness. But remember, even the laws of physics unfold through local actions. Every particle interacts only with its nearest neighbours, and yet together they create galaxies. The universe doesn't need control, it needs connection. The same is true for us. Our lives are small interactions in the cosmic web, but each carries weight. The kindness you show today may echo through countless unseen branches, altering futures you'll never know. You won't hear the echoes, but they'll be there, folded into the music of possibility. Archipov's story is proof of that. His calm decision, made in the suffocating dark of a submarine, changed the trajectory of billions of lives, not because he was extraordinary, but because he trusted reason over fear. The branch we inhabit, this peaceful version of Earth still spinning beneath the stars, exists because one man remembered that uncertainty is not the same as danger. It's humbling to realize that the fate of a species could hinge on such a quiet act, and it makes you wonder how many other invisible Archipovs have shaped the world without ever knowing it. How many times history has branched toward survival, not because of miracles, but because someone chose to wait, to listen, to breathe. The universe, for all its grandeur, is built on such moments. Not explosions or revelations, but pauses. The still points where chaos could have rushed in but didn't. Maybe that's what the physicist Niels Bohr meant when he said, "The opposite of a profound truth may be another profound truth. In this case, the truth of survival lies in contradiction. We live because someone didn't act. We move forward because someone stayed still. So as you breathe now, know that you're participating in that same act of quiet continuation. You're part of the branch that chose patience, empathy, and endurance, the one where life continued. The next time you read the news or see the chaos of the world, try to remember this hidden symmetry. Somewhere, every moment, someone is choosing the branch of peace, and the world bends, almost invisibly, toward survival again. If the multiverse truly exists, then perhaps compassion is its guiding equation, not written in numbers but in actions, in all the times we resist the easy path of reaction and instead choose understanding. And maybe that's what Archipov taught us without ever knowing it, that the survival of worlds doesn't depend on brilliance but on the calm courage to say not yet. As we drift toward the closing of our journey, this realization grows softer but more luminous. The story of the universe may be vast beyond measure, but the story of us, the humans who look up at it, fragile and curious, is written in tiny mercies. And if you listen closely, you can almost hear the echo of those choices humming through time, like a heartbeat. It's the sound of the world still existing, the sound of the branch we chose together. As the night deepens, the story folds inward again, from global history to the quiet interior of thought. The chaos of the world fades, and what remains is something tender, a recognition that every moment we live is one among countless possibilities. Somewhere, another you made a different choice. Somewhere, another you didn't turn back. Somewhere, another you is still wondering what became of the path you took instead. This isn't fantasy or mysticism. It's what physics, in its calm way, seems to imply. In the many worlds interpretation, every decision, every toss of a coin, every blink of an eye, every heartbeat, creates a branching of reality. The universe, rather than choosing, keeps everything. Nothing is deleted, it only diverges. Each path continues quietly and independently, with its own you at the centre. believing they are the only one. It's a strange comfort, isn't it? The thought that somewhere, every what if is answered. Every regret, every hope, every almost lived out fully somewhere beyond your reach. You don't feel those other lives, but they exist in the same great fabric of being, woven from the same initial spark that became you. The philosopher Peter Lewis once phrased it gently. At any future time, there is a branch containing a living successor of you. He didn't mean a clone or a ghost, but a continuation, another instance of the same pattern of thought and matter, still exploring, still feeling, still alive. If you picture that idea softly, it begins to look less like immortality and more like echo. A sound doesn't cease the instant it's made. It ripples through space, bouncing off walls, fading, overlapping with new sounds. Consciousness might do something similar, not by defying death, but by resonating across possibility. You're not one echo, but the chord made by all of them together. Imagine standing in a vast hall and whispering your name. The first sound reaches your ears, followed by countless reflections of the same word. Some strong, some faint, all yours, each one real in its own layer of air. You can't follow them all, but you know they're there. The universe might work that way, an endless reverberation of selves, each carrying a note of your existence through the corridors of time. But what does that mean for this you, the one listening now, breathing quietly, tracing these words through the dark? It means that your life, this branch, still holds a unique weight. The other versions may exist, but they don't diminish this one. In fact, they make it more precious. Because in the infinity of possibilities, it's astonishing that you ended up here, at this exact intersection of choices, in this exact moment. Sometimes, it helps to think of yourself as a point of focus in the great pattern, the way sunlight passing through a prism becomes a single bright beam. The light exists in many wavelengths, many colours, but only one gathers here now as you. It's the version that breathes, wonders, worries, hopes, and listens, and that's enough. The other versions of you, the ones scattered across an invisible world, might wonder too. They might look at the night sky and feel the same longing for meaning, the same desire to understand why consciousness feels so singular when reality seems so multiple. Maybe in their own way, they're listening to a quiet voice right now, hearing the same words through a different pattern of air. If you could meet those other selves, what would you tell them? Would you compare lives? Would you envy the versions who made luckier choices or pity the ones who didn't? Or would you smile, recognizing that each is carrying the same spark, the same curiosity that's carried through every branch since the beginning of time? Perhaps you would tell them that you're grateful, that together, across infinite realities, you form a mosaic of possibility, a living testament to what existence can be. No single version of you needs to bear the weight of perfection. You are all experiments in becoming, each mistake redeemed by another's success, each loss balanced by another's joy. If this sounds poetic, that's because it is. The language of science, when it brushes against the edges of identity, becomes indistinguishable from poetry. Probability becomes rhythm, equations become metaphors, the mathematics of branching turns into the music of being. In that sense, you're never truly alone. Even if you feel small beneath the stars, remember that you're accompanied, not only by other people, but by countless echoes of yourself, all walking their own paths through the great landscape of reality. The universe isn't an empty expanse, it's full of reflections. Some belong to others, some to you. All shimmer together, part of the same luminous field. And when you think of death in this context, it begins to soften. Maybe the end isn't an erasure, but a blending, a return to the vastness from which all branches spring. Somewhere, another version of you continues. Somewhere, a memory of you endures in the pattern of matter, in the way you changed others, in the way your thoughts shaped the air. Perhaps that's what we really mean when we speak of immortality, not endless life, but lasting influence, a continuation of resonance the universe remembers in its own way. Every action, every word, every kindness leaves a faint trace in the cosmic field. Physics tells us that information is never truly lost. It only disperses, and maybe the same is true for meaning. When you laugh, somewhere else another you laughs differently. When you cry, another you stays silent. Yet both are part of the same human chord. One melody played in endless variations. The important thing isn't which note you are, but that you're part of the song at all. So tonight, as you settle deeper into the quiet, you might imagine that this branch, this reality, is the one that pauses to rest. Somewhere, another version of you keeps working late, or walking beneath the stars, or listening to a different story entirely. And maybe they wonder about you too, the one who chose stillness, the one who, in this fragile slice of time, decided to breathe and let the universe drift through them instead of chasing it. And in that moment of wondering, the distance between branches disappears. All the versions of you across all the worlds align for a heartbeat, joined by the same question: what does it mean to be here, now, aware? That question is the thread connecting everything, the hum that never fades. It's what binds the multiverse not through mathematics, but through meaning. And as you listen to that hum, steady, quiet, endless, know that somewhere another you still wonders the same. You're part of that eternal curiosity, the consciousness through which the universe learns to feel itself alive. And so, we've reached the quiet end of our long journey. Not a conclusion, but a slowing heartbeat. The questions that began as thunder now settle into whispers. What began with physics has ended, as it always does, in wonder. The night around you feels different now, not emptier, but fuller. The silence hums. The air itself seems to carry the memory of everything we've explored. Quantum worlds, branching lives, the self that flickers, fades and returns. Take a breath. Feel the space you occupy. The small room, the soft darkness, the steady rhythm of your pulse. In all the vastness we've imagined, in all the universes we've let unfold, this is the one that matters most. The branch where you are still and aware. Every other version of you, the ones working, wandering, remembering or sleeping, are distant lights across a cosmic sea. But here, in this branch, the moment is whole. It's strange to think that sleep itself might be another form of branching, a surrender, a quiet collapse of awareness into something vaster. As your thoughts begin to drift, the boundaries between you and everything else start to blur. It's not death, not disappearance, just another kind of unfolding, a soft release into possibility. In some branch, you may already be asleep. In another, you're still listening. In another, the night hasn't even arrived yet. But all of them belong to the same infinite wave of being, and each carries you in its pattern. Perhaps this is the true gift of quantum immortality, not the promise of endless survival, but the realization that existence itself never runs out of ways to express you. Life and death, waking and dreaming, presence and absence. They're not opposites, but alternating verses of the same song. The melody never ends, it only changes key. If you could step outside of time and see all the branches at once, you might notice something beautiful. Every moment of your life, every thought, every kindness, every laugh, forms part of an intricate web, shimmering like dew on an endless field. Each droplet reflects countless others. You can't separate them. The whole universe is one vast, interconnected pattern of light, and consciousness is the glimmer that makes it visible. Physicists sometimes describe reality as a wave function, a single, mathematical shape that holds all possibilities at once. But we don't need the math to feel what that means. You felt it every time you watched a sunset and sensed something larger stirring behind the colour. You felt it when you reached for someone's hand and found it waiting. You felt it in the way memory folds time, letting you live the past and present together. Those moments are your glimpse of the wave, your proof that everything, in some way, remains connected. And if you listen closely, you might sense that the universe itself is falling asleep with you now. The stars outside burn in slow rhythm, like embers in a hearth. Galaxies turn gently, as if rocking themselves to rest. Somewhere, light is still being born, somewhere else it is fading. But across all of it, one constant hum continues, the vibration of existence, soft and patient. You're part of that hum. You always were. It's comforting to know that even in an infinite cosmos, meaning isn't something we have to find. It's something we feel. The equations describe how the world behaves, but the heart describes what it's like to live inside it. Somewhere, Everett's equations still unfold, branches still multiply, waves still interfere. But here, in this small slice of space-time, there's only the steady warmth of being, the feeling of life holding you like the surface of water holds a floating leaf. Maybe that's the quiet lesson of all these ideas, that you don't need to conquer infinity to belong to it. You already do. Every heartbeat, every breath, every gentle thought ripples outward through the fabric of reality, leaving a trace that will never be erased. The laws of physics say that information is never lost, and so, in their quiet way, they promise that neither are you. When you close your eyes tonight, imagine the universe is unfolding softly around you, some bright, some dim, all filled with stories still being written. In one, you're already dreaming. In another, you're still awake, listening to the final words of this story, feeling your mind slow and settle. In another, you're far in the future, remembering this moment as something that once felt eternal. And through it all runs a single thread, the gentle truth that consciousness, in all its forms, is the universe noticing itself. You are that noticing. You are that moment of awareness, carried by starlight and atoms, by memory and chance. The universe has never forgotten you, because you were never separate from it. So sleep softly in all possible worlds. Somewhere you are already at rest, somewhere you are still beginning. Somewhere you are the echo of what once was, and somewhere else you are the possibility that has not yet arrived. Every version of you breathes together in the quiet rhythm of existence, rising and falling like the tide against the shores of eternity. If there's a way to define peace, perhaps it's this: to realize that you never truly leave the story. You're written into the structure of reality itself, a line of poetry in the cosmic language. You don't need to hold on to anything, because nothing real is ever lost. Every kindness you've given, every moment of wonder you've felt, remains woven into the light that fills the universe. And now, as the voice fades and the night deepens, let that truth settle around you like a blanket. Let the branches of the universe drift gently apart, carrying their infinite versions of you into sleep. Somewhere, another you keeps watching the stars. Somewhere, another you keeps searching for meaning. Somewhere, another you has already found it, in this exact moment, in the quiet between one breath and the next. You don't live in one universe. You live in all the moments that choose to remember you. And tonight, as the soft music of existence plays on, you are exactly where you belong. Here, in this world, in this breath, in this quiet. Good night, traveller, rest well, you're already home.